how we roll, man. Some rock, some win, some 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 win, man. Some rock, some win, some roll, man. Some rock, some win, some roll. Some rock, some win, some roll, man. Some rock, some win, some win. Some rock, some win, some roll, man. 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 cool, way less. My crew, the best. never get it anyway. Conquering the impossible, all with a smile on our face. Grind all day, we dance all night. With body speaks of nature, with body speaks, grind.
Sure. Excellent. Thank you. So I'm Andy. I'm going to talk about FIRST culture and ethics. I think officially this is the second time I've given this presentation. I gave it out at the FIRST Mentor Conference this past August in San Francisco, San Jose area. So who are the veterans in the room? How many veterans? This is like your second or third season. Okay, I see you. I see hands. So who are the new people, new rookies and such? Okay, that's fine. Hey, welcome. That's cool. So I'm going to use a slide. I'm going to get it started here. And actually, hang on. Let me share my screen. So you can see what my slide is. Okay, do you see this FIRST ethics and culture? Is that, you guys see that? Yes? I can't see you, so, oh, yes, thank you. All right, good. So first of all, who am I? I'm a husband and a father, first of all. That's my wife on the left, my three daughters. They all have been pivotal. And FIRST, all my three daughters were FIRST students, were FIRST leaders, and they're still FIRST volunteers now that they're out of high school. And my youngest is a senior at Purdue. My older two are out in the workforce, making us proud. And I really truly believe that FIRST is a great place for a diverse group of students and adults to mix. I'll get to that later. I'm FIRST mentor and volunteer. I've been a mentor since 1998, and I'm president of AndyMark, and I was the 2003 Championship Woody Flowers Award winner. But really, with this slide, I really can't do what I'm doing without the support of those four women there. So before we get into culture and mission, or culture and ethics of FIRST and some of the details, we veterans, well, I think this has actually been updated like within the past week, and I didn't update my slide. So check out the new FIRST mission and vision. They've changed some of their wording of this. They've made it a little more streamlined. I was kind of surprised by that, and I've been busy this week, so I didn't update my slide, but that's some news. So check out FIRST website for their updated mission. But we as veterans should often go to the website to see what's up, look at study their core values. I think I know FLL does a great job with regard to getting the kids to talk about core values: discovery, innovation, impact, inclusion, teamwork, and fun. Gracious professionalism and cooperation are key terms that we use often within FIRST. And then more than robots is something they've been using a lot lately, last 5-10 years, that FIRST is more than just robotics. So my point here is, as we lead new FIRST members on our teams, and maybe new teams, and for the job of us veterans is to make sure people know where they can go get more information about this information. firstinspires.org. Hide that. And then we can talk about this throughout the year. And this will kind of be some of our North Star direction that we can follow as we deal with culture and ethics. So the founders of FIRST, it's important to know, Dean Kamen is the founder. He is the primary founder. He's an inventor. He really is the impetus behind our inspiration. He inspires many of us. He gives us homework assignments at events. He connects people together. He with some help, he founded FIRST in 1989, and it became a competition in 1992. He's an excellent fundraiser. He gets big companies come in and give FIRST funds. And right now he leads DECA, which is a huge research. Well, it's a pretty big research organization. They have like, I don't know, maybe like 800 engineers working on development projects for various customers. And they're based in Manchester, New Hampshire, right near where FIRST is based and on their headquarters. Dr. Murphy is, I consider him a co-founder. He helped Dean found FIRST. He's an inventor. The origin, I have an origin story with Dean. So Dr. Murphy is an older gentleman. He actually recently turned 100 years old. And then 2 days ago, he passed away. So rest in peace, Dr. Murphy. Yeah, 2 days ago. So here's to you, Dr. Murphy. But the story goes that Dr. Murphy and Dean were working on a project in New York City when this is like in the 80s. And Dr. Murphy's dad, Dr. William Murphy Sr., won a Nobel Prize for the development, I think, of vitamin B. And that helped out people's health. It made us, helped out the vitamin business industry, and it helped people become healthier. And so he received a Nobel Prize. And so he was telling Dean about this, and Dean's like, well, where is this prize? Where is the prize? Where is the medal? And he said, well, it's in a closet somewhere. It's up on a shelf. He says, well, that's a shame. People should know about your father's Nobel Prize. Kids should know about who these monumental role models are for science and technology and writing and health and all this stuff. And kids should emulate heroes who are making the world a better place instead of emulating heroes that hit balls with sticks or put basketballs through hoops. We should do something about that. So they started thinking, and they went along and they found Woody Flowers, who also passed away recently in 2019, but he was running a class at MIT called, I actually don't know what the name of it was, but 2.007, they've renamed it. And the challenge of that class was to take a kit of parts and follow the rules of a new game every year and compete against other students in the MIT class. Sound familiar? So it was a robotics competition. It was not so much team-based, but it was individual-based, and they would have a new challenge every year. And Dr. Murphy and Dean thought that was pretty cool, so they recruited Woody to be a part of this new thing called FIRST, and here we go. So the beginning of FIRST was really founded by Dean with the help of Dr. Murphy and Dr. Flowers. Woody is considered the father of competitive robotics because of what he did at MIT. He coined the terms cooperation and gracious professionalism. And if you go on YouTube and look around, you can find a lot of stuff on Woody. Recently there were some really good videos that were called the good stuff videos, and I would recommend looking up those. I'm going to try to show you one here soon if the audio visual works correctly. Gracious professionalism is a key mantra term for us to use within FIRST, and in my opinion, it's competing in the hardest and the most passionate way you can, while still being gracious to your competitors. So you might help them out as they get ready for the match, or you might go see how they're doing if something broke after the match. But you are still gracious, even though you're trying to win against them during a competition. So Dr. Murphy, because he liked Woody's communication skills so well, he created the Woody Flowers Award, and 1996, he gave Woody the first Woody Flowers Award. So if you ever wonder, if you ever ask, well, who's the first Woody Flowers Award winner? Well, it was Woody. There are 28 championship Woody Flowers Award winners. There's 1,042 Woody Flowers Finalist Award winners. Those are given at district events, regional events, and the winners are really supposed to emulate Woody's spirit, and they act. Our group of championship Woody Flowers Award winners, we act as advisors to FIRST, and then we act as strong community leaders. I'm sure you have strong community leaders in your areas that are the Woody Flowers Award winners and the Woody Flowers Finalist Award winners, and they're supposed to be like the champions for team ethics. So, who cares about this stuff? Culture and ethics. Who cares, right? I would hope. I don't see you right now, but I would hope that you care. So CARES is an acronym I'm going to use. I'm going to talk about culture, accountability, rules, ethics, and support. Culture. Okay, FIRST has changed a lot over the 30 years it's been around. Initially, what happened was companies were challenged in 1992, or actually 91, to form teams to compete in 92. So Dean and his colleagues went out and asked companies, Xerox, GM, Ford, Johnson & Johnson, and also universities, MIT, WPI, other universities, to form teams and go get some high school kids to be on your team, and we're going to give you a challenge of this robotic game, and you're going to compete. So the first year there were 28 teams. From 1992 to 1998, it was a one-on-one competition. Every team was for themselves. You went to a match. All you wanted to do was beat the other team in that match. There were judges. There were pits, just like there are now. But seriously, in 1998, that was my first year. In 1998, I vividly remember in our pit, there'd be kids working on the robot, adults working around the robot, helping the kids, whatever. And if someone came up to our pit, they would ask how our robot works, what does it do during the match. We were not incentivized at all to tell them what that robot did. We kept secrets, and we didn't tell competitors what a robot did because there were not alliances back then. The only people that we told really everything were the judges. So the judges got the whole spiel, but other teams really had no business, or there wasn't any incentive for us to tell other teams how we played the game, what we did in the match, what our best attributes were, what our drivetrain was, all that stuff. So in 1999, FIRST, actually at kickoff, it was quite impactful. We already paid our money. We registered in September, October. We go to kickoff in 1999, and they say things are going to change. Every single match you're going to be in, you're going to be partnered with another robot. So you have to depend on this other robot to play this game of FIRST. And most of us were kind of mad about that. We were like, what? We paid our money, and now we have to depend on this other team we have no control over to win the match? That's kooky. That's crazy. So we don't want to do that. But then by the end of the year, kids were collaborating. They were opening up. They were sharing each other's designs. Teams were saying, here's what our best attributes are during these matches. Teams were marketing to each other. It was magical. It was amazing. And within those 2-3 months of between January and March, that change was the biggest impactful thing that ever happened in FIRST, the onset of alliances in 1999. It went from less communicative, more secretive, less likely to help others, to we were excited to talk about the robots. We had a strong desire to help other teams compete at the top of their game. Then it got even more crazy when we went from 2 versus 2 to 3 versus 3 in 2005. So that was an exciting time also. But the alliance onset in 99 was a big, huge deal. Accountability. So team accountability, individual accountability, supplier accountability. Part of our culture, part of our world within FIRST is for us to get along, for us to cooperate, and for us to have gracious professionalism is to be accountable. I've seen teams be accountable for things they do bad. I've seen teams not be accountable for things that they do bad, and it takes sometimes years for them to recover from that. Teams, like whenever I would be a field coach, if I'm a field coach with my drivers, I know that everybody's watching us, and I have to make sure if something goes sideways during the match and such, there's frustration. It's not good. We always save the frustration or save the passion about what went wrong and such for a private moment, not in front of the whole arena. You don't yell at your driver or well, you shouldn't do that anyway, but you shouldn't really be debating and pointing and expressing yourselves loudly until you really get away from where people can't see you. So be careful regarding your frustration after matches. Let things cool down and then go through the issues as a team privately. There's been times. There was a team back in the middle 2000s. We would run IRI. So IRI is a off-season event held in Indiana, and it got to be popular enough. It was an invite-only event, and people would apply to come compete. And then me and some other guys, Chris Foltz, Jeff Smith, me, we would decide who is actually on the invite list. So if we have 120 applicants, we would have maybe 60 or 70 invites. That means that 50 or so teams are not happy, but they didn't get invited to IRI. So there was a team at one point that would come every year, and they were a very, very successful team. But every year, without fail, they would be complaining about stuff. They'd be saying, "We don't like this. We don't like that." And they were just kind of jerks about how the event would go, or how, that's not how it is where they're from. And they were just like, you know what, you don't have to come. It's like, gosh, guys, this is an off-season event. So there was another year where they were one of those teams that wasn't quite as good as they were, and they didn't get invited, and that was frustrating to them. We talked about it afterwards. I talked about it afterwards. Was like, hey, if you guys come every year and you're just complaining about it, why should we invite you when there's other teams that want to come in? So they eventually were accountable for their actions. We held them accountable. It was kind of tough, but that was a way for a team to kind of learn a lesson over the years. And we had to talk it through with them and get them to be a better team and be a more positive team. And now they're still good friends, and they're good people in the community. Some examples of individual accountability I've seen, like I have a good story. Sorry. I remember having a student a couple years ago that we were out of stock of a part, and shame on us, we actually accepted an order for that part that was out of stock, because I think they got their order in right at the end of when the stock was available at Andy Mark. And we let them know that, hey, this isn't going to be able to ship for a couple weeks. It was in the middle of build season, and they were darn frustrated. So I had a student email me, and they said, well, this is inappropriate. You should do a better job of managing your inventory. You shouldn't take the order if you don't have it in stock. He's right. But they said, this is a big bait and switch, and you stole my money. You're a thief. I'm like, whoa, I'm a thief? Well, I don't like that. That's a low blow. That's kind of fighting words there. So I was writing an email back to him. I'm going to teach you a lesson, blah, 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 blah. And I'm typing this email, and I pulled in some fellow staff members, and they read my email and said, don't send that email. You got to tone it down. Andy, you're still a mentor on these teams. You got to back off. You're hot head right now. and you need to take a break. Don't send the email yet. Just because he called you a thief, you don't need to rip the kid. So I actually changed the email, and I said, okay, I'm going to ignore the whole thief thing. And actually, his teacher was copied on the note. So I had the teacher on my note back to him, and I said, I'm going to ignore the thief thing, but yes, I'm going to address all these issues. Here's why it was out of stock. I'm sorry about that, this and that. And it was a well-written letter after my colleagues got me off the ledge there. The teacher emailed me back and said, oh my gosh, I did not expect that kid to send this email. I'm so sorry. He didn't check with me before he sent the email. But it's all good. It's fine. He said that the kid is, he's really passionate about these things, and he's sorry, but he just went too far. So that year at Champs, I'm walking through the pits, that teacher grabs me, and I end up able to talk to the kid. We get a picture together. We're smiling, we're laughing, water under the bridge, no big deal. I'm actually I really appreciate the teacher and the student both for wanting to say hi to me at Champs. And the student was accountable for his actions. The teacher was accountable for the student's action. I had some good people to help make sure I didn't make a mistake when I fired back at the kid. And it was a good example of accountability with regard to individual actions. Supplier accountability. We make mistakes often. We do a lot here at Andy Mark, and I always say the people that don't ever make mistakes are the people that don't do much. And if we do a lot, then it's hard to bat 1,000. So we do make some mistakes. I think when we react to customer feedback, we want to be very accountable. I think also if there's something that goes wrong with maybe our product with a supplier or some interaction between those suppliers, that gets difficult sometimes. There's been some times when we have some of our supplier to supplier relations are difficult, but usually time does heal those wounds, and we talk it through, and we do have a positive interaction with suppliers. There could be a lot of stories with that. I'm not going to get into the details of that, but I think what I want to say there is, in our community, the suppliers who support FIRST the best are the ones who really are accountable for their actions, and they're accountable in the end to the students and the teams who really want to use their products. So I'll say if there's anything that you want from us that you think we did wrong, you can always send an email to customer support or customer service at andymark.com, or you can call us and say, hey, what's up with this? I think this is wrong, and we can talk about it. Often also a lesson there is if we see something that went wrong and we're catching it first and it's not seen out in the market yet, this is just basic business 101. If you tell your customers that something's wrong before they noticed what it is, they will be much more forgiving to you as opposed to them coming to you with the problem and say, hey, your product has this issue. And you always come out shining brighter if you are proactive about the issue and accountable ahead of time to the customer before they know about it. Okay, rules. It's hard to be accountable. It's hard to get people to be aware of things if they don't know the rules. And not everybody knows the rules exactly the same. Not everybody has the same exact interpretation of the rules. But when your mentors and your veterans tell you to read the manual, then you need to read the manual. And it's not just the robot manual, but it's like YPP rules. Every team should have a very strong mentor-student like contact relation rule. That's been a heightened focus this year for student safety. Every team should have a safety protocol with regard to mentors, like too deep mentoring, those types of rules with regard to how teams are ran. It's not just about robot rules. This is also how teams operate themselves. There's also event rules, like from safety in the pits to seat saving in the stands, which you shouldn't do. You need to know these rules. Make sure you communicate these rules, not only to be safe, but also just to be gracious to your competitors at the event. That's part of our culture is following these. These are our rules, and we need to follow them. Volunteers have rules. Mentors, suppliers, they all have rules and roles that they serve to support FIRST. But really, the focus should be making sure the teams have a great experience. So for many years, I was a head ref. This is me being a head ref in Oklahoma City in 2008. That was a great, fun group there. And one of the pieces of advice that not only Woody Flowers, but also FIRST management would tell me is like when you're working through a rule issue with a team and you're trying to be as fair, consistent as you can, there's always an instance where it's not quite black and white, and you got to do your best to make the right judgment. And the advice I got from Woody was that if you're in that spot, always side on the betterment of the team. Now, if it's black and white and the team needs to be disqualified, yeah, you got to disqualify them because that's fair to the rest of the teams. But if there's something that is really a nuance it's hard to understand exactly what the final rule is, please side on the team's on the team side that you're ruling against. When you make those types of rules, maybe as a lead robot inspector or an FTA or a head referee, you got to include the students in your rule discussion. If you're the volunteer, and if you're a mentor, you got to work through those rule discussions with your team. And I would recommend strongly you don't just blame people for rules to be broken. I would expect those teams who get disqualified or have issues that come at them, please use these as a learning experience, not as a chance to pile on against volunteers. Okay, ethics. Now I might need some verbal feedback here, but let's see if this video works. Okay, hopefully you guys heard that. That was good. Yes, was that good? Did you hear it? Ah, shoot. Okay, so maybe at the end we can try to do that again. Well, okay, so it's on YouTube. Woody Flowers, good stuff, ethics. That's my search suggestion for that. But what he was talking about was we as teams need to really decide where we stand on some ethical issues. So my slide here says, okay, clearly it's bad to steal. If you're at an event, there's a laptop in your neighbor's pit. It's bad to steal a laptop. It's bad to steal another team's award entry, like verbiage or their video or whatever. It's obviously bad to sabotage the radios at the Duluth Regional or whatever event you're going to. It's bad to disable somebody else's robot. There is a path for reporting bad issues in your mind, and there's a non-medical incident report, like event managers, like people that run the events. They help students and teams file reports for people that are inappropriate or situations that are inappropriate, and sometimes those are subjective and not as bad as others. But there's been many years, there's been sadly just bad things that have happened because our community is pretty darn big. We want to minimize those things as much as we can, but they still do happen. My advice in that area is act quickly, report it to event management, and address the issue that day, that time with the person that did the thing that was wrong. Like if there's a student, this happened in Indiana 3 or 4 years ago, there's a student that's writing abusive things on flyers that are on the wall, then that day, that student needs to figure out that that was not right. It's better off to handle it as soon as possible. But these are clearly bad. These things that, pretty obvious. The thing that gets harder with your team is some of the things teams think are perfectly fine and other teams think are not perfectly fine. Some examples. Some teams really, they are notorious and they are famous for seeking out the loopholes within the game. Every year they come up with a really novel idea or a unique solution to the game, and other teams might think that's borderline cheating. That like, well, why are you always trying to lawyer the rules, or why are you trying to look for a way not to play the game that FIRST wants us to play? That's not gracious professional. So everybody thinks a little bit differently with regard to some of these subjects. The use of other robot designs or parts of other teams, especially if you don't give them credit or ask permission. Like if you're using somebody else's design that you saw, maybe you saw someone use it successfully, I would recommend that if you use someone else's design, I would give them credit for it. It's a hot topic or debate to have a student or an adult drive coach. Some teams are passionate about not having adults behind the glass coaching the students. Other teams, they think it's a good opportunity for the adult to mentor not only the students on their teams, but be a positive mentor to students on other teams. That is a decision your team has to make. That's your own team's ethics and decision on what's great for your team. Like some teams are so popular. Another example would be some teams are so popular that they have like 200 students apply to be on the team. So that means you have to cut away you have to actually cut students and not allow every single student be on their team. So is that gracious to not let every kid be on a team? For some teams, that's fine. Other teams, that's not fine. So these are ethics that are more gray and not as black and white. Like another topic that's kind of a hot topic would be just adult involvement on the team. Some teams believe the adults really shouldn't be turning wrench or fixing things on the robot or even designing things or coding things. It should all be students. Other teams believe this is a mentor program and the students need to see what the mentors do professionally. So seeing the mentors design, seeing them fix things and program things is a good part of FIRST. And that's a debate that still happens. And every team needs to figure out where they are on that scale of gray between this is great or this is bad. Support. We as a community are, I think every year we get more supportive of each other. There's lots of different types of people in FIRST. We have a lot of folks in FIRST, from older folks, younger folks, different races, different economic backgrounds, different sexual orientations, different religions. I think like I cannot imagine what's happening like in Israel right now with regard to diverse teams in Israel. So there's Jewish teams and there's Arab teams in Israel that are all on FIRST, and I'm hoping somehow they can make it through a season and they can have events, and it's going to be a challenge for them, and it's going to be hard for them to sometimes be in the same room or the same event together, and that'll be difficult because there's a war going on. It's just really hard. That's kind of an extreme case, but that's part of our world, sadly. I think as we talk about support, I think anytime you're working on anything with a new robot, or your robotics team, from fundraising to the robot itself to programming to CAD design or whatever, leadership, the more you empower the students, the more you support the students, no matter their age, their ethnic background, their ability. The more you support them, the better off you're going to be. And I think along that way, if you respect diversity and empower students who are minorities, I think that's a wonderful thing. As we relate to each other within our community, there's a lot of cross-team collaboration. I always tell our students to, as we go to an event, try to talk to students on other teams, try to talk to adults on other teams, and they're going to give you support also. You might, there's a lot that happens amongst teams that collaborate together, like taking multiple teams on the same bus to go to championships, or multiple teams having the same workspace and competition field, or doing outreach events together, or hosting off-season events together. You don't see, at least I don't see, sports teams doing that as much as robotics teams. I think robotics teams, part of our culture is the fact that we support each other, even though we compete against each other. Sometimes there's even coaches and mentors on multiple teams. They're supporting multiple teams, and that's a great thing. So the culture of support within FIRST is strong, and we need to keep that going. So some actions, some homework actions, just kind of review. Culture, know your basics, propagate our culture by sharing your stories. You older folks, older students, older mentors, please share your stories, like I was sharing some old stories, and hold each other accountable. You got to still have respect for each other, but if you see somebody veering off of something and not doing something that they should be doing, tap them on the shoulder and hold them accountable for what they're doing. Read your rules, understand your rules, not just about the robot, but your team, your tournament, the game rules, all that stuff. And then have the exercise of deciding on your team ethics. How is your team structured? How do you run your team? How much are your students empowered? Who's the drive coach? All that stuff. And then continue to help each other and support each other in our community, and it's going to continue to be great. So I got some time. Thank you for letting me do this. I think we can talk about some stuff if we want. Let me stop sharing. You got any questions about anything I talked about? You guys are quiet. Maybe it's early. It's early up there. Yes, in the back. Could someone repeat that? I think the main thing that the term gracious professionalism is a really genius term. It includes respect for each other as we're gracious toward each other. Professionalism means we're kind of, we're not lazy, we're not slackers, we're not unprofessional, and we're competing in a manner that is gracious with our team and against other teams. So I think gracious professionalism, kind of slurred there. I think if you lean on that one as the most important part of our culture, I'll go with that. Good question. That's a great question. It's hard. Yeah, we try to. We've had our challenges. We've had some really difficult challenges this year. We've had I think when Mark and I started the company back in 2004, we started out of our garages, and it was really hard. But it was him and me and his wife Emily and my wife Mary, and those four people, we knew each other pretty well, and it's easy back then to deal with ethics and culture because it's just you four people. So once we started hiring people, we're like, oh shoot, we gotta somehow do a mind meld and get our opinions into these other people and our culture into these other people. And so we I think it was 2008 or 2009, we created our own mission and our own goals for a company, and we talk about those a lot. But even so, there's people that sometimes do things that surprise us. Granted, 99% of the people that have worked here have been fabulous, and they do wonderful things, and they really are a great example of our culture, FIRST culture, and we try to emulate what FIRST is doing. So yes, we try to emulate and we try to follow the FIRST culture within Handy Mark. Yeah, go ahead in the front. How do we make sure students are holding themselves accountable? If we have a contact with a student as a company, so I'll answer it in two ways: as a coach on a team and as a company. As a company and as a coach, whenever I'm talking to a student through email or electronic means, I always have another mentor or another adult on the email. And usually if it's anybody on my team or anybody on a team that we're dealing with as a company, I try to include that teacher or that mentor, that key mentor, so they see the conversation that's going on. So if a student does something that I see that's wrong, as a not a teacher, I try to include the teacher with that communication first of all, and then teachers are more educated and well equipped to handle issues with students than I am even as a 28-year member or mentor. So get the teacher's advice, get the teacher involved, get the school staff member involved. If it's not a school organization, then get leaders of that organization involved with the student. Make sure when you're addressing the issue, it's not just you and the student. There needs to be at least a third person in the room, so it's not just a he said, she said type of thing. And even though you're trying to get the student to do to be accountable for something that they did, I assume they did something wrong, right? And even though they did something wrong, it doesn't mean they're a bad person. You have to make sure that you maintain a level of respect and gracious professionalism toward that student. It's hard. Sometimes that's hard, but try not to pass judgment that they're a bad person, even though they did something that wasn't the best. So separate the action from the person. But yeah, include a teacher or leadership of the team. Have more than just you and the person talk about the issue. Have 3 people talk about it. Address the issue. Don't think the person's bad just because the issue was bad. Yeah, in the back with the hat. How do I confront people who are not being gracious? First thing I might do is have them repeat what they just said, or what if they're being, let's say they're being disrespectful to a teammate or to someone else. Often to disarm them, you have them repeat what they just said. Like, hey, that was a racist joke. You're thinking to yourself, that was a racist joke. Maybe you can say, hey, could you repeat that? I'm not quite sure what you said. And if they say it again, then you're darn well sure that they meant what they said. If they take it back and they say, well, and, they might not say it again if they know it's the wrong thing to say, and then they're kind of becoming accountable already. But I would have them repeat what they just said. I wouldn't initially admonish them in front of everybody. I would try to pull them aside, probably with a teacher or with someone else, and pull them aside and say, hey, Johnny, what's going on? This isn't good. You just told us all to F off or something like that. That's not that's actually happened to me a couple of years, 2 years ago. One of our students didn't like something, told us all off, and was mad at the whole team. And so we pulled him aside and said, hey, you can't do this. Well, do what? And he wasn't accountable at all for what he said. He said, well, I blacked out. And I said, no, you didn't. You said this. You had to be accountable for this. Doesn't mean you're a terrible person, but why you can't do these things. So just like I said, try to take the issue away from the person. Maybe have them repeat what they said just to make sure it's clear. Pull them aside and try to correct them. You don't have to beat them down in front of everybody. That's hard not to do sometimes. But I always try to correct privately and praise publicly. So if someone does something really well, praise them in front of everybody. But if they don't do something very well, try to pull them aside and correct them. And you student leaders, you're going to have to do those things too. It's not cool as a student leader to call out another student and embarrass them in front of the whole team if they did something wrong. You might have to just pull them aside and say, hey, Susie, you didn't get this done. You said you were supposed to get this done. Why not? It's better to do that privately than it is in front of the rest of your team. Unless it's repeated. Yeah, there's a time and a place for the more public correction, but definitely not the first time. What else you got? So my request is go find Woody's Good Stuff Ethics video on YouTube. So check it out. If you don't know Woody, sadly he passed away maybe before many of you got involved on the team, but he's really brilliant, and I would recommend searching his old videos. Thank you all. Have a good rest of your day.
bands, bitch, you're picking up the brains, but the beat is in my pants. Yeah, I'm picking up the bands, going psycho. Beat, you suck like lipo. That's the biggest sandwich. I'ma take on that bite though. Like savages, we go ramming it. No bandages for those cracks in it. So hazardous, the main mansion it. So cavernous, when I cracked the skull, I had the bliss. I got so excited, I had to piss. I imagine it, I'm finna manifest. And if I manifest, and if I have you been, then I'm damaging it. Yeah, I'm back to winning, yeah. I'm back to quitting myself, my prison got shit to finish, yeah. I had a minute, yeah. Ain't at the limit, no. I'm back to winning, I'm back to business, I'm back to finish, yeah. I'm back to winning. All your stuff like cash me up. I don't got shit, who's asking? If it don't fit, I'm passing. If I go in, I'm blasting. Let me go home like Manson. Let me taste blood like Manson. Let me taste blood, I put it through handsome. Let me get up like laughing. Hitting the curve, no crash. I said he back, I said he dripping, no drip, no check. I swear I'm running this shit like Jack. Play with my penis, I'm putting it back. I'm putting it back, making it shit, I'm making it smack. Make it so hard that it crack, yeah. Making it kick with a crack, yeah. I'm back to bad at bitch, she bad at shit, I'm bad at this. I got the benefits, I managed this, I had to hit. I meant the father figure from above. I wish he had his figured at me when I showed him love. I'm back to winning, yeah. I'm back to quitting myself, my prison got shit to finish, yeah. I had a minute, yeah. Ain't at the limit, no. I'm back to winning, I'm back to business, I'm back to finish, yeah. I'm back to winning. All your stuff like cash me up. Wish you had my little.
Some swag and some books and stuff. I'm going to get started. Is that okay, Todd? Okay. Totally cool to flip through that book. Make sure you get stickers. That's why we sent it. My name is Greg Needel. I am the Rev Robotics president, co-founder. I am a FIRST alumni. About 23 years ago, I was a student in a high school on a FRC team, just like you. I've been doing this for a lot of years, and I've held a lot of roles. I still mentor a team. I'm a lead robot inspector, and we do a lot of stuff with Rev. I went to RIT in Rochester, so I am very familiar with what it's like to be cold, even though I'm hanging out down here in Texas. I have a lot of patents to my name. I think innovation and protecting innovation is an important thing. And then I also captain Team Switchback on the TV show BattleBots, if you guys are familiar with that program. I want to start by saying, you know, Rev is one company, but we have really two brands or two different core product lines that we support FIRST with. We have Rev Ion and Rev Duo. This presentation, because it's this is a very FRC jumpstart, we're going to focus more on the Rev Ion product line. But I do want to kind of point out the Rev Duo system. Many of you who participate in FTC or might have seen this in your classrooms, because it's used in a lot of schools, is two different scales. So when we build, we kind of have the Rev Ion stuff, which builds big robots, and we have the Rev Duo stuff that builds kind of smaller classroom ready stuff. But for the rest of this presentation, I'm going to mainly focus on Rev Ion product lines. Rev Ion is something that we launched actually about a year and a half ago now. And the whole purpose of Rev Ion was it's a series of parts that is both electrical and mechanical that just seamlessly work together. And we're really trying to help teams make things work so that you can build the robot that you want to build instead of being limited by, oh, I don't have the ability to fabricate this part, or I'm worried that this electrical connection is not going to work well. We want to enable you to build the robot that you want to build and take your ideas and make them real. And so that's kind of the underlying premise of Rev Ion, is that it can serve a number of different purposes. From teams who have no resources can build full robots out of it. Teams who have lots of manufacturing resources can use this as a prototyping platform. And what we've seen is that there's kind of some hybrid. There are some teams that build entire mechanisms and stuff out of it, and then they augment that with custom parts, or kind of, but it all exists, and it's trying to eliminate some of the frustrations that have previously existed in this. This will be our 2024 will be our third year of the new Rev control system components. So I think that, so when you put your robot together, there are a bunch of mandatory products that you have to use on your robot, and Rev makes many of them. And so you have the main core robot controller for FRC is the National Instruments RoboRIO, but around that controller you have, you need to do power distribution, you need to do motor control, you need to do power your radio. If you use pneumatics, you power pneumatics, and Rev makes many of those products. These are relatively new. They came out, like I said, this is the third season of them. I presume that many of you have seen these devices, but I'm going to kind of go through them in case there are some rookies or some folks who haven't gotten to play with them yet. So the main kind of core device that we make is called the Power Distribution Hub. It is where all of the current on your robot gets distributed. So your main battery goes to the breaker, and then it goes into this device, and then every other thing on your robot gets power through this device. So this device has 20 channels of high current, so up to 40 amps, and then it's got some low current channels. So the nice part about this, and this is the improvement over the previous ones that FIRST had, is that now any slot on this device, you can put basically any motor that you want to pull the maximum current, which is a nice opportunity. So all your motors and things would be attached to the top levers in the orientation of this photo, and then where your main feed from your main breaker or your battery would go in at the two bigger ones at the bottom. You'll also notice that there is those yellow and green connectors. Those are for CAN communication, and there's also a USB-C connector on this. So this device is actually a smart device, so you're able to get in real time the voltage of your whole system, the current on every individual channel. One of these channels is switchable, so you can act as like it's got an integrated, almost like a relay, but it's really designed to give you some smart feedback. So you're like, wait a second, my battery voltage goes too low, maybe I'm going to turn something off on my robot. So at the basic level, it just distributes power, but it also gives you the ability to make smarter robot control decisions based on that sensor feedback. We also make the individual resetting breakers. So every channel will need a breaker. And that's how these are really there to protect for, they are a current to, they are there and they do break at certain currents, but really these are there to try to protect your robot from fire and main short type of thing. So two main wires on a motor controller shorting out is going to pull current way high. Most motor controllers these days have smart current limits, so you should be doing your current limiting in software, and these are the kind of the backstop for those software current limits. The pneumatic hub, if your team uses pneumatics, this is kind of an all-in-one device for pneumatics. So you would hook your compressor up to this, and this will take signals and turn your compressor on and off. You have to plug in a pressure sensor, which is a either an analog sensor, which gives you the exact pressure of your system, or a digital sensor, which just gives you, am I over, and it's going to turn the compressor off at a certain PSI. You are only limited in FIRST Robotics, according to last year's rules and presumably the year's rules coming up, to 120 PSI at your storage. So this device will self-regulate your system, and you don't really actually have to do anything in code to do that. You hook the compressor up, you hook the sensor up, and it just does its thing. And then for actually actuating pneumatics, you would plug your solenoid valves into each one of the channels, and then you can switch on and off your pneumatics. Pneumatics are really great for a lot of reasons. If you haven't explored them for your robot, there's a lot of really great resources out there on pneumatics in general. Some of the reasons you might consider pneumatics is that they're very, they're binary in the sense that they are either on or off. And that makes it really easy to, like, if you want to deploy an intake, for example, a pneumatic is a great way to do that because it can be out or in. Whereas if you use a motor, you have to build a motor, build a gearbox, and then that gives you a little bit more variability. So there is a balancing act with pneumatics that says pneumatics are very quick and fast, but you only get it's all the way out or it's all the way in, whereas motors give you that full range of motion. Also with pneumatics, you have to deal with, you have to have the compressor on board. And so the physical volume of the stuff you need is quite bigger. But if you're going to run pneumatics, this is it. It's a device that also talks on CAN or USB as well. This next one is one that I hope I see on everybody's robots. This is how you power your radio. The radio that you use for the Wi-Fi on your robot does not have an internal regulator in it. So if it's just hooked to 12 volts and your battery drops down in voltage, your radio will reset. That's not great. So this device, what it does is it boosts the voltage coming from the main battery, and then it gives the radio a constant voltage supply. So with this device, your radio, even if your battery drops down low at the end of the match, your radio will stay powered. This device is really easy to use. There's no programming, there's no configuration, there's no CAN, there's no communication. You literally just feed it 2 wires from the main power distribution, and then you connect your Ethernet cables between your RoboRIO to this and then this to your radio. And it uses power over Ethernet to inject that power into your radio. So it's pretty much as bulletproof as you can possibly get. Some people might be familiar with the voltage regulator module, which is the way we used to do this. My only warning is you don't want to stack a voltage regulator and the radio power module. You just want the radio power module going right to the power distribution hub. We saw some teams wiring it that way last year, and 2 regulators in a row can create some issues. But this is incredibly simple and designed to keep your radio up and running. Spark Max, the Spark Max motor controller has been our kind of flagship main motor controller. It's been in the kit of parts now going on 5 years or so. It drives both brushed or brushless motors, works over CAN or PWM. You can configure it through the Rev hardware client or over parameters in your code. It's got integrated closed loop control. And it pretty much, this will drive any motor that is FRC legal that does not have an integrated motor controller to it. So it will drive any motor basically except for the Falcon or the Kraken that have their own integrated motor controllers to it. And so this is You probably have some of these in your shop or on your robot. Neo brushless motors. So Rev has an entire line of motor products. We call them Neos. That Neo is the family of the motor controllers, and we now have 3. So new for this year, we just launched the Neo Vortex. I have a whole slide about the Neo Vortex itself, but you may be familiar with the Neo and the Neo 550. And so effectively, both the Neo Vortex and the Neo are both your high power motors. You can use them on drivetrain, your shooters, your lifters, your elevators, your type of things. Your Neo 550 is an incredibly powerful motor, but it's really where it shines is in small places like your intakes, conveyors, and high-speed mechanisms. That's where it really shines, and it really, from a packaging perspective, it's really nice because of how small it is. All right, so new for this year, we launched the Spark Flex and the Neo Vortex. So this is kind of the really big product for us this year. We took all the feedback over the last 5 years of the Neo and the Spark Max, and we redesigned this platform. So the main differences with this is that this is a dockable motor and motor controller package. So the motor controller separates from the motor. So they are still 2 pieces, but you can put them together directly, which means the encoder cables between the brushless motors and the motor controller are physical connections. They're no longer wires that might get snipped. And so you would just feed this motor controller, the Spark Flex, just 12-volt power, and then everything is all in one power. This is pretty similar to the experience that you get, with a Falcon, but the difference being is that because these are separatable, if you happen to burn out your motor or a motor controller, or you need to change something around, you can independently replace the 2 devices. That also means that the motor controller is useful for other things beyond just this motor. The other really interesting things and highlight features to talk about on this is that this is a through-bore motor. So it's kind of the first of its kind. It has a 1/2-inch hex through bore, so it has no shaft in the motor itself. So what that means is literally you can put this motor on any hex shaft in your entire robot, but we also make specialized shafts for different applications. So we have a gear shaft. So instead of taking a gear and putting that on a pinion, or take a pinion, put it on a shaft with a keyway and work down that way, you just directly have gear that is on your shaft directly. There is a direct coupler for the Max Planetary gearbox so that you don't have to deal with the coupler and the keyway and all that stuff. It just goes directly together. And then there's some other shafts that will also replicate. There's both the Falcon shaft, input shaft, but also there'll be the Kraken shaft. So as ecosystemly, if you want to eliminate all the keys out of your system, you can do that with this. But also it works with any size hex shaft. So this can directly be driven by a 1/2-inch hex shaft of any length, which is kind of a neat new thing. So I think that teams will find some really interesting places to put this on their robot. And we really think this one, this motor and motor platform will serve teams very well for the next years to come. I do think it's important to note, we are not getting rid of the Neo 550 or Spark Max. These are additional to that. And so you will still get support for Spark Max and Neo for years to come. This is just an additional platform that we're adding for this season. So talking specifically about the actual Spark Flex part of this motor controller, this motor controller is designed that it can work both with the motor, with the Vortex, or standalone. So there'll be a dock that comes out that allows you to use this totally independently. And it features all the things that are inside of Spark Max, but it also adds a whole bunch of new capabilities. Some big ones that we know people will be happy with. It now has reverse polarity protection, so you won't burn a motor controller because of a simple wiring mistake. The data port has been totally overhauled. It's got a brand new locking connector on it. And we also have some new interface stuff that's coming out. I'm not ready to spill all the beans on that yet, but you'll be able to talk to this motor controller through the data port using additional protocols and things that have never been possible before. We also have some new control modes that are going to be coming out, and this will work with the Neo or any of the backwards things. So the nice part about this ecosystem is that if you think about it from a 4-quadrant perspective, we have the Spark Max and the Neo that have gone together for a long time. We have an adapter that allows you to drive the new Vortex motor from a Spark Max. So you don't need to buy new motor controllers to get the new through-bore motor. And then we have the new motor controller that has a bunch of features. And then also there'll be an adapter that allows you to run this independently. So then you can drive your old Neos, your Sims, your 775s, or anything else off the new motor controller. So whichever kind of direction that your team wants to go, all this stuff is designed to work. So that's one of the big things that we try to work on when we're designing new products, is to make sure that things are backwards compatible, so that you don't have to, oh, there's a new product, well, all the old stuff is now junk, right? We want to make sure that there's a cohesive ecosystem that you can adopt over time, or kind of make sure things, you get the best value for the money that your team fundraises. And so these are available now to pre-order, and they will ship by kickoff. They're en route to us now, so these are coming hot off the presses. Rev Hardware Client. The Rev Hardware Client is our core piece of software. The easiest way to describe it is that it is kind of the do-everything talk to Rev products. If it has CAN or USB on it, if you plug it into a computer or connect to it on a computer, you will be able to configure, modify, change the parameters, anything you want to do, firmware update within the hardware client. It is a one place, whether you are an FTC team and it's a control hub or a driver hub, or you're an FRC team and it's a Spark Max or a power distribution hub or anything. The Rev Hardware Client is an all-in-one place to do that. One of the things I do like to highlight on the hardware client, because not a lot of teams have maybe seen this, is we have this tab up at the top called telemetry. And what telemetry is all about is it's all about real-time data feedback, maybe before your robot is even set up. So if you take one of our motor and motor controllers and plug it into the computer and give it power, and you can real-time drive that motor, but you can also just spin that motor, see the current, see its RPM. You can mess with PID parameters. You can see a lot of stuff. So think about it in this context. You're building a prototype intake on your robot. Maybe you have that on hex shafts. So now you could take the Spark Flex and Neo Vortex, which has a hex shaft. You could drop that right onto that prototype, run this over the hardware client, and then get your speed, how much current it draws, and everything, so that you can make smarter decisions. This is a much better way to prototype, because if you just use a drill to drive an intake, you don't actually know, like, what's the power of that drill compared to the motor that I'm going to actually want to use on my final robot. This way you get some actual practical data, but you don't need to set up the whole control system to make it work. Obviously, you still need to be safe. You know, I recommend putting breakers and things in line and not just like plugging these right directly into a battery. But this telemetry can give you a lot of information on the current in your system. If you have encoders or you've got positional that's running back through your motor controllers, anything that is available to you inside of code, and we've got a pretty extensive documentation on this, can basically be displayed in real time on this graph. And then you can save that data as a CSV file and analyze it. So if you wanted to prototype a shooter, you can mess with your PID, see how fast it takes for your spinner flywheel to recover, and then take that data back and say, oh, I want to mess with the gear ratio, or I'm going to change the current limit. And by upping the current limit, it recovers faster. There's a lot of really core engineering development tools that you can get, and it's just integrated into our regular software. So that's something that you should play around with, especially during the prototype part of the season. Going into the mechanical side, just like we've done on the electrical side, where we're trying to make it so that just everything kind of intuitively goes together, we've done that on the mechanical side as well. It all kind of starts with our max tube, and we do have several new sizes of this that we'll be announcing this year, but the max tube is patterned aluminum. It's pre-drilled, and everything is on a 1/2-inch grid. So everything just kind of bolts together and works. The biggest feature here is that if you notice that that hole in the middle, those are all on 2-inch spacings. So we call that hole, which you would see on our wheels and some of our gears and the tubing, this is max spline. So the inside 6 pedals will support a standard 1.125 bearing, but also the outside is really great for torque transfer. So we have a shaft that goes through that allows you to do giant torque transfer through those holes, but also any of these can support a standard bearing hole. This hole, the geometry on this hole is designed that it can be 3D printed or CNC'd or any type of machining. So if you want to make a custom intake, or you're a team that wants to 3D print something that interfaces, you can grab the CAD and just, it will directly work. That's a lot harder in like a 1/2-inch hex, for example, to transfer that geometry to custom parts. But where this really starts to shine is in things that are on pitch. So for example, on the with 20 DP gears, which is what most of our Rev Ion gears, if you have 2 gears that have a center to center, that have a total number of 80 teeth, so you add up the teeth and the total count is 80, that means that the center to center distance of those gears is 2 inches, which works perfectly on this tubing. So I want to create a little gear ratio. I can say, oh, look, 20 to 60, right? That's a 3-to-1 gear ratio that's on an exact center to center distance. But wait a second, I want a quick change. That's not the right ratio. Well, now let me grab 2 40 to 40 gears, and it's as simple as sliding the gears off, putting the different gears on, and you can change the ratio without remachining a plate or doing kind of any other thing. Because this is a even pitch system, that also means that 25 sprockets and chain are also even pitch. So any 1-to-1 sprocket and chain works there. And then we also have a belt standard that's called RT25 that gives you a bunch of belt and pulley options that are all going to work on this pitch too. So that the idea here is just rapid iteration. That's kind of the fundamental part of Rev Ion. Is if you ask any of the top teams, what they will tell you is the secret to their success is the speed that they go. And whether that is their ability to custom manufacture parts really quickly or just roll through prototypings, the faster that you create and validate your designs, the quicker you're going to find the mistakes in your design so that you can fix that for the next one. If it takes you 2 weeks to design an intake for your robot, during the 6-week build series, you might only get 3 intakes. Whereas if you can design an intake in 1 week, now you can get 6 of them. If you can design an intake in a day, now you can have 42 of them, right? So it's all about speed, because you don't want to show up at the competition with version 1 of your intake, because I promise you version 1 will not be the best version your robot can build, but you need to go faster in order to have a 1, a 2, a 3. And so that's kind of what we're trying to provide, is a platform that people can iterate very quickly. Even if these parts are not the final parts in your robot, it can use as a prototyping platform. And then Ion has lots and lots of parts. So everything: wheels, gears, brackets, gussets, tube, sprockets, standoffs, hardware. It's designed to be very interchangeable, and the parts are designed to be reusable. So everything uses a 1032 screw. Everything, that means that basically you can put together and take apart your whole robot with a 5/32 or an 1/8" Allen wrench and a 3/8 wrench. And it all just kind of designed to fit together and to work. So all of our wheels have the max spline. That means that all of our wheels can either be a dead axle where they've got bearings in the wheel, or you can put a hub in it and convert it to hex, or you can drive it with a max spline tube if you've got high torque. So it's all just designed to kind of work together as a cohesive system of parts. We intentionally do not have every option of gear and every option of, like every possible combination, because we're trying to say these are the most common ones, and to kind of enable you to go faster without having to worry about, well, I have a 64 tooth gear and a thing. We want to provide you the options that are going to work on pitch and work kind of in the scale of the system. But we are constantly adding new products to this. A couple core features of core products that are in this that we think enable you to go fast. We have a max planetary gearbox. This has been out for several seasons. It's overbuilt for FRC. Let's just be honest. It is way stronger than it needs to be for the motors that are being plugged into it. But the idea is just, it goes together, it works. You're probably not going to break it. And the individual stages of this are pre-assembled and pre-lubricated. So you just can swap out cartridges however you want. We have a 3, a 4, and a 5-to-1 gear ratio. So you can multiply those as you go. And then also, I'm not going to tell you which one yet, but there is another gear ratio coming out for this season. And then we have compatibility with the Vortex through a direct shaft, but we will also have a Kraken spline input kit that's going to be coming out in January for people who have elected to go with the new Kraken motors. So you will have ability to put all this together regardless of which motor you choose. 3-inch max swerve. We launched this last year. For the most part, it went well. We had some wheel issues last year. Some of you probably saw some teams scrambling about their wheels. The modules were never the issue. It was just the wheels. So we've redesigned the entire wheel, and we have a 2.0 wheel, which is really designed now, and it will last an entire event. We also still have metal wheel options if you want to run tread instead of running the rubber wheels. But these are the lowest cost swerve option that you can get on the FRC market. So if your team is thinking swerve, and I think probably honestly every team is thinking swerve a little bit, this is a pretty good option. I know that there are teams in your area that have used it. You can reach out to them and get a more, I'm biased, I think they're great, but I also, get your own feedback. And these are available now too. So we have these in stock. We have plenty of them either in stock or en route to us, so that the idea that you can just buy them whenever you need them, there's no waiting time on these. It's just a regular product for us now. So ultimately, the build system is all about making iteration fast. When we designed it, we designed a whole bunch of robots and to try. So how would we replicate that? How would we do this? And that's what Rev Ion is really all about. I do want to point out a couple other things. Since last year, we've also launched this this on-shape application examples library. So we have designed a whole bunch of little just mechanisms out of Rev Ion, and they're all on our website. There's a link here, but if you just go to docs.revrobotics.com, you'll be able to see those. But you can see them as a picture, but you can also just open them in Onshape. So even if you're not an Onshape CAD user, or even if your team is not a CAD team, you can click them in your browser window without logging in, spin them, measure them, see how stuff is assembled. And in the case of like a swerve drivetrain, if you want, you can literally just grab that CAD file and just drag it in as a base of your robot, make a copy, change everything. We release a lot of files in Onshape because we find that being able to see it, turn it, spin it, really gives people an idea of how to build with this stuff. And you can pretty much build anything that you can put your mind to. And so this application examples are designed to show you how to do things. that you may not know on your own. And we're constantly coming up with new ones, and we're going to keep expanding this library of available CAD. The other thing I want to talk about is the Rev Starter Bot. We've done this for FTC for the past 3 years, and we did our first one for FRC last year. Basically, we design a robot that plays about 65 to 75% of the game, and it is all built out of Rev Ion. Yes, it can seem like this is a sales thing for Rev Ion, but the other idea here is that this is a robot that you can build to get started if you don't know where to start. And the nice part about what our program is as compared to like EveryBot is there's really no cutting, custom machining, or anything in this robot. So if you're like, hey, I built this robot, and you get into it and you're like, oh, I want to design a new intake, you take those parts apart, you can reconfigure them, and maybe you have to buy a little bit of extra tubing or some extra hex shaft, but you're not going to like custom machine every part of this, which is I really do love the EveryBot program, but one of the pieces of feedback we've gotten on it is that it's like you have to custom machine all these parts, and then if you want to evolve as a season, you kind of have to start over. The starter bot is designed to be a starter foundation. So we will be releasing the 2024 starter bot within the first week of build season. Our goal is actually to release it on Monday of the first week of build season. We do not expect this robot to win the world championship. Do not build this robot thinking it will win the world championship, but we think that this will give you a scaffolding of a place to start, or at least to share what we think about, or maybe how to use some of the parts for a robot that you want to build. And that'll be located at that link. And we also will release the code and the CAD and every part of it. We are not trying to steal your team's aha, but we do recognize that there are a lot of teams out there that just don't know where to begin. FIRST is releasing a robot this year at kickoff, which is designed around the kit chassis, which will be, I've never seen it. I don't know what it is, but it's designed to be built with stuff in the kit and stuff from like Home Depot or local suppliers. And so between that program, the EveryBot program that 118 does, and the starter bot, hopefully we'll give you some ideas if you want them. If not, create your own ideas and your own thing. We just put it out there as a resource. I put team sponsorship out here. I want everybody to know about a couple things. So first of all, every single year, at least for the last few years, Rev has donated $50 to every single team. So that is a pure donation. Your team has $50 of Rev credit that you can spend in your FIRST dashboard now. Please go spend it. Every year, I'm surprised that we get a lot of teams that don't use those funds. You can go and buy things on Rev's website that are less than $50, right? So you can go get shaft collars or shafts or individual parts that cost you nothing but the shipping to get it to you, and that is free for everyone. We also have a sponsorship program called Team Rev. I know you have some Team Rev teams in your area, but we give out a $100,000, a little actually more than that this year, and sponsor a bunch of teams. We look for teams that want to be successful in all elements of being a team, whether it's supporting, they are a good performer on the field. They do a lot of the community stuff that would be good for the Impact Award, but also they're just good teams that want to support their communities. So look for those Rev teams to maybe, if you need local support, you can obviously always reach out to us, but there are probably teams in your region that can help you with this stuff. The program's closed for this year already. We've already selected our teams, but we do open this up every summer in July. And we do not have, our program is set up that there will be teams that carry on year to year, but we will have new teams every single year. So it's more of a sponsorship program than like that team, every team has a shot to do this. We get an incredible number of applicants, but we encourage you to apply because we want this to go to teams that need it. Another one that I want to plug before I get to questions is the Open Alliance. How many people know about the Open Alliance? Okay. So the Open Alliance is not directly Rev related, but the Open Alliance is a group of teams that have come together that basically say, we are going to just open up our build season. So they generally have threads on Chief Delphi or on their websites. There's a Discord, but they are like totally open about their prototyping, their CAD, their everything about them. So you can go and follow along and get ideas. I think that everybody in this room or every team probably played with a robot that had a part on it that came from an Open Alliance team, whether you knew it or not. So last year, for example, Team 111 Wild Stang came up with this really cool intake. They posted on their Open Alliance, all the CAD, all the details on it. And then a lot of teams around FIRST took that and then made it their own. So the Open Alliance is a fantastic resource. It also happens that a lot of Open Alliance teams also happen to be Team Rev teams. There is a crossover there. And then I host a weekly show on Fun that is where we talk to Open Alliance teams and ask them questions about how they discovered things, what their process. So if you've got limited prototyping capabilities, or you just want to see what other teams are doing and how they're thinking, tuning into the Open Alliance as part of the build season is a pretty valuable resource. Oh yeah, and I always leave this group with a couple new product teasers of stuff that's coming out. We have these cool new little flappers that are coming out to add to our compliant wheel line. These come in all the different durometers, and they're just kind of flappy. So if you have irregular shaped game objects or things like that, that's what they're really designed for. We will have these in both 1/2" hex and also 5mm hex for the duo FTC teams. And then the sprocket on the other side of the screen these are billet sprockets that we're coming out with. So we've done plate sprockets before, but what happens is under high loads, a lot of times those plate sprockets will want to bend. So for arms or for heavy load things, these are machined out of billet, so they have a lot of thickness. So these are a lot stronger and can be used in a lot of different places on your robot. So both of these will be available on our website soon, but for this season for sure. And that's the presentation. I think we still have time for questions. So I'm gonna stop sharing my screen here so you can see my pretty face, and I'm happy to answer any questions that you have. We don't have pricing for the dock yet. So if you want to use the Spark Flex with the normal Neo, there'll be an adapter. We don't have final pricing on it. To be very transparent, that product is the slowest of all the things that we're working on for Spark Flex and Vortex, but it is not going to be expensive. It's in the call it $20 to $30 range is what it's going to end up being. Sure. Yeah. So we updated and released. We updated our 2023 RevLib to 24 so that it's compatible. We have a whole bunch of new software libraries and things as part of RevLib, and a lot of it actually has to do with some of the new features inside of the Spark Flex and the Vortex. We are targeting a release of that this month. But it's all kind of a thing because we're trying to get the motor controllers and everything all together all at once. But I would look for a full release of that in all the libraries. The latest would be kickoff, but it's not changing significantly. We are adding a lot of features to support the new motor controllers. So we're trying to do non-breaking changes on all the new stuff. Yeah, so Rev will be putting in a proposal for the control system. That's something that we've been working on. I can't really talk more about it just right this second, but it is something that we are going to be putting a proposal in. Any other questions? They are different. The process of testing to get to the V2 wheels was pretty intense because we knew we couldn't mess this up. But no, we've run these wheels at several off-season events. I think that you had some 1.1s. I think were the ones that you tested last season. The 2.0s are significantly better. We actually changed the material, the core material, to get better mechanical adhesion between the plastic core and the rubber, chemical adhesion. And then we also modified the geometry of the wheel to get better mechanical adhesion. So there's some material differences and there's some changes to the actual wheels. They still work on the modules. But the rubber will basically, it is effectively impossible to roll the rubber off the wheel now. And so the wearing is just wearing the wheel. So you'll be able to run them significantly longer because the majority of teams' failures was rolling the rubber off the side, and there was still plenty of material there. And ultimately, we learned from our own kind of failure is that when you take a side hit on a robot, that energy was just too much for the bond that we had. So that was something we did, and we did a lot of fun impact testing to determine if these wheels were good enough. But we had some of our local teams running them in off seasons, and we feel really good about the 2.0 wheels. 2.0 wheels are shipping right now, so every swerve module you would get now has a 2.0 wheel. And if they're not on our website for sale already, they will be very soon. But they're very good, and like my team will run them, 3005 will run them. Like we really love the rubber wheels as compared to the treaded wheels, and we think that we've finally gotten the compound and everything correct, that it will get the performance that people want. Sure. So, well, let me tell you a couple of things. So we did some crazy testing on Vortex to put it, I don't have a picture to share of this. I wouldn't actually worry too much about this. We did a test where we had a shaft coming out the backside of this motor with a huge mass on it, and we basically were trying to run the thing until it failed. I would not worry too much about the cantilever loading on this. The bearings are high quality. You're probably going to be okay. I will say one of the things, and I guess I haven't really pointed this out to many people specifically, but if you look at the front of the actual motor, this is recessed sized for the flange of a regular 1.875 bearing. So if you are bolting this up to a piece of tube, it doesn't hurt to put another bearing here and then support the shaft. Obviously, we encourage you to support the shafts. If you're running this with a giant piece of hex shaft like this, sure, put bearings at the end of this. Don't just leave this cantilevered, but it's not going to be any worse than like a normal motor. And in many cases, it's going to be better because the bearings are significantly bigger in the motor than like the bearings that are in like the Neo or the Falcon, for example. So I wouldn't worry too much about it, but yeah, if you're going to put a long shaft on this, tail support it with another bearing. That's just good mechanical practice. Any other questions? All right. Well, I appreciate you giving me time. I hope you learned something. And like I said, if you've got any questions, feel free to reach out to us on support. We do have a bunch of new stuff that we're still announcing for the season, and we're excited to see what you guys build with it.
decisions need to be made. We're leaving all the choices up to fate. We've only just met, but we know there's something deeper, can't forget. It feels so good, it feels so true. The only substance I need is you. It feels so right, it feels so true. Taking in every single drop of you. I know our hearts are protected. Never will we be disconnected. I know our hearts are protected. Never will we be disconnected.
Right, Logan? Let's start. Ready, Dylan? Yep. All right, let's get started here. We're a couple minutes late, but we're going to get through this. We're also streaming this on Funds Updates, First Updates Now website. And this one, we're going to talk about a lot of different things with the control system, dealing up to date. I'm Todd Cruz. I'm the head coach of 8516 Wired Up, and I'm also a control system advisor. I've been in robotics for over 10 years now. And so we've seen a lot of things in the field at these competitions, both all season and during the competition season. Logan over there is going to speak here in a minute. Logan is 4607 alumni and also a CSA as well that helps us. And our job as a CSA is to keep all the robots running. We're the bridge from the field to the pits. So you'll see us with orange hats running around the events, trying to keep everyone up and running. And then we sometimes make appearance by the field to make sure everything's run there, and the FTAs communicate pretty regularly with us on there. You ready, Logan?
Yeah.
You want to introduce yourself a little more?
So I am Logan Steffen. I'm an electrical programming mentor for 4607 here. I started on the team as a student in 2014, where the shirt came from. And I am now a mentor there, as well as a CSA from Minnesota. So we're the guys that walk around with orange hats. You'll see me at the events. That's what I do.
What we're going to cover is complete Rev and CTRE's control systems, how to configure them, how to put firmware in there, how to do the CAN IDs on there, doing your RoboRIO image on there. That has to be done no matter what. We'll talk more in a minute about that. And what needs to be updated for the season coming up in 2024. Also, we can talk about radio configuration, driver station overview with debug help, the radio configurations with, and also tips and tricks of everything that go along with it as we see and things we see when we're troubleshooting robots at events. So just give a quick overview snapshot. If you're going to use the complete CTRE control system, which a lot of you guys don't use anymore, but that's what it looked like. You have your power distribution board in the middle, you have your speed controller, motor controllers all on the left there, you have your pneumatic system tied in there with all the things with that, with your solenoids, compressor, relief valves, and your switch that sees if it's in the right pressure or not. And then of course you get your RoboRIO and your radio over to the right there, and any other I/O that comes off of that. If you're using a Rev system, this would be if you use 100% the Rev system. There's a slight difference in the components there. You'll see the difference in the pneumatic hub and the radio. With the, instead of the VRM, you would see the power over Ethernet module right there, and then we go right to the radio there, and then you still have all the rest of things in. Now, a lot of teams are using a mix of these, which is perfectly legal as far as we know for 2024, but we'll pay attention to the rules when they come out at kickoff. Now we're going to talk about the RoboRIO imaging 1 and 2. So go ahead, Logan.
Yeah, so the main heart of your control system, if you're not familiar with it, or maybe you're new to this, the RoboRIO, that's these gray boxes here. I have version 1 as well as version 2 up here, since we'll sell them since they're a little bit different. But this is the heart of your control system. Your code runs there, all the devices connect back to there, the networking goes through there, that's what your driver station talks to. That is the heart of your robot. So to image this, every year there's going to be a new image released from NI, who is the vendor who develops all the software for it. And there's a couple different ways we have to do that. For this version 1, it's done over USB, so that's this cable here. It's like a big square printer cable, if you've ever looked at those. And on the newer one, it actually uses a little micro SD card. So kind of like you put in a camera, GoPro, thing like that. And this is kind of how that would look. You have to install the NI game tools every year, so that's just a program you put on your laptop. It installs the driver station, the RoboRIO imaging tool, as well as some other utilities. And it'll look like that on your desktop. And this is what that program actually looks like. So in that imaging utility, when you plug it into your RIO like this, you should see it pop up in that left box up there. It'll show like RoboRIO and then your team number, or if it's a new RoboRIO, it'll be zeros. But with this, it's super easy. You just select the image in that box on the right, hit format, and wait about 5–10 minutes. It takes a little bit, just writes it to it, and you're good to go there.
Yeah, so things that catch a lot of teams on this point here is you see the IP address of 172.22.11.2. There's a driver that is installed with the NI toolkit that will take this cable that you plug in USB to your laptop, and it'll create a Ethernet adapter that will reconfigure it. And a lot of teams get hung up that it doesn't connect. You cannot do this through the Ethernet port. You have to use USB cable.
Yep. Yeah, so it's just kind of a step-by-step of what you do with it. First, you click on it. You have to enter your team number, since that actually sets the IP address of the RoboRIO. So that's how your computer, as well as other devices, know how to talk to it. And that IP address is based on your team number, so that's really important. Then you would hit Format Target. That other button is for updating firmware. As far as I know, they have not updated the actual firmware of the RoboRIO in years now. So that's probably going to be fine for yours. But you'll hit Format Target, and then in that Select Image box, you just click whatever the newest image is. I think it's 2024 1.1 right now. Then you hit Format. Then you just wait a little bit. So yeah, then you'll see that progress bar come up. It'll show a dialog box at the end that says it's complete, here's your IP address, and you're good to go there. And if you have issues with it, this happens really often at events when people are in a hurry or things are moving around. Sometimes that cable will get bumped and it'll get interrupted in the middle of it, so you'll get an error like this. Usually you can fix it by just retrying it. Sometimes something else happened to it. And you can try by accessing it through that local IP address that's up there. So that's that IP that gets created by the USB cable. If you can access it there, then you can usually see what happened to it. You can see what version it's on. You can check its IP address. Most of the time, you just have to restart it. Every once in a while, you might have to do a full reset of the RoboRIO. There's a reset button on it that you essentially just hold down. And then should be good.
Rare case, you might have to go into safe mode on there and do it.
Yep.
Or else get in touch with one of us CSAs and we'll probably help you out on that.
Yep. Yeah, so this is the other big thing. On Windows laptops, they have a firewall enabled by default. This is a huge headache for FRC Robotics in general. That firewall tends to block a lot of the network communications that you need to actually talk to your robot, as well as do this process. So one of the first troubleshooting steps is just to turn that off, and you can just search for it, Windows Firewall in the search bar, you'll see it pop up. And
especially when you first start up you start up the new install, it will probably ask you, if your firewalls turn on, it'll ask you to add it, an exception to it. And sometimes if you don't get quick enough, you might have to shut it down and restart it again to make the connection.
Yeah, then that other thing was just talking about the firmware updates. That was a thing that hasn't changed in a few years now, but if for some reason it does, you might have to do the firmware update on top of the imaging. The RoboRIO 2, so that's this newer one that came out a year or two now ago. That's this guy right here. The biggest telltale that you can tell to RoboRIO 2 is it has this different logo on it. It doesn't say LabVIEW on it like the old one does. It also has an SD card slot. So this one is a little different because the image and the software that runs on this RoboRIO is on that SD card. It's not inside the RIO itself. So we have to take that SD card out and we got to put it into a computer. So with this, in that same RoboRIO tool, on that window on the right, you'll see that SD card icon, that little circled folder icon. If you hit that, it'll open a dialog box that shows where this image is. It's just a big zip file. And then you're going to use some tool to write to the SD card. So if you've ever used a Raspberry Pi, you probably had to image those before. It's the same utility like that. Raspberry Pi imager, Boolean Etcher is another really popular one. You just select that, you select the blue button to pick that file where that it showed you when you hit that SD card button. Yep, just like that. Then you hit open and you'll write it to that SD card. Really simple. Then you eject it and you put that in your RoboRIO. And then this is really important. So that image that you wrote to the SD card does not know who you are. It doesn't know your team number, it's just a blank image. So when that's done, you would actually take this USB cable, plug it into there just like the old one, and then you have to go back to that utility and you set your team number. So for that, you would just type in your team number, hit edit startup settings, and then apply. And then it's all good.
Very important. Do not forget that. You will not communicate with it.
Yep.
Again, it talks about firmware and that as well on there.
So this is another thing that comes up sometimes at events, especially when you're in a hurry. That file that they hide for the RoboRIO image is kind of hidden. So there's the full path where it is, but I think they've improved it this year, where if you hit the SD card folder icon, it'll take you straight to it. So pretty easy to get to now.
So devices updates, what is needed to be updated and why? So what I tell teams is, please don't show up to the event with 2023 code going into 2024. Please update them ahead of time so when we get to the regional event, you're ready to go with at least the new software. It's not an option. If you're using the Rev stuff, or excuse me, the CTRE stuff, they have an old legacy one with the old Phoenix tuner here, and this will come up and you can browse it and just put some temporary tool set onto the RoboRIO to find all your devices. And once you do this, you can bring this up here and you can select each one to add new firmware. The first thing I like to do is set your CAN ID. Get your little piece of paper out, write it down so your programmer knows what motor, which manipulator, actuator, any other thing you're running on your robot has the proper CAN ID so you can program it correctly. Then you come in here and select it, and you can write the firmware to it. This utility will let you write to all of them, to all alike ones. So if you have a bunch of Falcons down there, or the Krakens on the other utility we'll show you in a moment, is you can select them all and then write them all to it. Usually you don't have to go find it. It's usually linked up correctly on here. The other thing that comes up is if you do not know which device you're talking to when you're setting the CAN ID, because if you have all brand new Falcons on your robot and you plug it in and you set this utility, you're only going to find one because they're factory defaulted CAN 0. So you'd be like, hey, there's something wrong with the wire. First thing you can do is change the CAN ID and then the next one will pop up in the line it finds. And you set that one. If you don't know, there's a flash utility and there you can blink it. And I'm sure it should be on this screen here where you can select that device and hit the blink function. We'll show you that in a minute where you can flash it and it'll sit there and go back and forth with orange lights on there to tell you which device you're talking to. The other devices on there, if you're using the old PCM module or the Mac control module, that one not to be due. They haven't changed any firmware in that in a long time. And the power distribution board, if you're still using the CTRE, make sure it's got the current firmware on there as well. It's very important to get the correct firmware on there. A lot of times the FTIs will come to us and say Team X has an issue with incompatible firmware. The FMS system is smart enough to detect that and sometimes will cause field issues. It's not a field issue, it's your robot issue that you don't run the right firmware on there and it may not communicate properly. The new Phoenix Tuner X here, very good utility. We were playing with it this morning a little bit and we're going to switch to it right now so we can look at it closer connected to a board. When it comes up, it'll have all the devices on here and it's got color coded on here. The color codes on here will tell us what's wrong. So when we click on a device like this Victor SPX here, it comes up here and it says new firmware is available now on it. Again, you got to have the USB into the RoboRIO to see all your CAN devices. It's got to be wired correctly, daisy chain. And one point about the daisy chain, make sure you have a terminating resistor on the end. So I like to start the RoboRIO, go through all my devices and end at the power distribution board. There's a switch on the new Rev board, and there's a jumper on the CTRE board that will terminate it and return it back so you can see all your devices. So on here, I can hit the blink feature on there, and you should see it blinking on there. So it's really fast on there. Now I know which device I'm looking at, and then I can hit the button here to update the firmware. If I hit the browse button, and it doesn't blink like I should, and I thought it was linked correctly. Yeah, that's a good one, Logan. So we're all going to learn together because I'm not sure where they put it. New device. I have to look that up after. Should come. I'm surprised they didn't default it. And this is the beta one anyway on here for the 2024 on here. We should all do that and update it and it'll come back with it. If you hit the refresh button on here, it will give you all the status on here, what the controller is doing currently. It's got limit switches on there, it's got an encoder on there, plug it through there from the dot board, and it's got a clear function on here. If you ever see them in a default, like a sticky fault, they'll be flashing back and forth on you, and then you come in here and clear it. Here's the Falcon here. Same thing here, this one's already been updated. It's got unknown because it's got the beta firmware in it right now. But if I hit the refresh button on here, it's like in the old Phoenix Tuner where you would do a self-test. Take a snapshot of it, this is what this is going to do, and you can see a LED state on here. It gives you all the information about that device as well. It shows it will also show some of the other ones on here too. It's got the Mac hub on here and everything else, and the PCM board. The other one is the Rev board. I actually found it on here, but you can't do anything with it. And so here you can take a snapshot. If you had your board up and running, wanted to know if that solenoid was on, you could go here and look at the state of each one of them as well. Very cool utility on here to do it. Again, if you didn't know, you can see the CAN ID's 25 on this one. And what a lot of times like I like to do is when you got your devices, I like to put the name of it. It's front motor left, or it's the intake motor, or it's the nuclear arm. You would put a name on it and then set it, and then it'll write into the flash. So every time you boot it up, it will have everything in there that you can see, and you don't have to go back to some sheet of paper, you don't know what it is. Is there any questions on the Phoenix Tuner? Things on that? If you're using the Rev stuff, the Rev hardware client that we just talked to Greg Needel on has what's called the Rev client on here. Very similar as you see in the Phoenix Tuner on there. We can flip to that one as well here. And you can see a device on here. You can see the Spark Max right here. This is where you have to pay attention in the configurations if you're using a brushless motor or a brush motor. Not many people are using the brush motors anymore, like the old sim motors, but you make sure that you put the right type right here. say brush for that, because they used to burn spark maxes out if you're trying to run something that's not configured right, especially when you're on a brushless motor on a brush configuration. Same thing here, it's got the sticky clear faults on here. You can see I can clear a few of them on here and burn to flash. If you had an absolute encoder on here, that would come up in here, especially your swerve drives. You can bring that up here, zero it, and then burn into the flash for your absolute encoder settings on here. On here, this tells me with the symbol on there, with the exclamation point, that it is out of date for your firmware on here. And then I can hit the update button right here. This is a little more intuitive than the Phoenix one was. Maybe it doesn't like the long cable, but you should be able to update it. Yeah, you can do the drop down and put any version you want on here. But the same thing on here when you look at the CAN devices on here. A lot of the other ones that are not your Spark Maxes on here, you don't have to put anything that's zero on it unless you're using two of them. But here's the CAN ID right here. Make sure you do it, and then make sure you hit burn to flash. Because if you don't burn the flash, you're gonna come back to it and it's still gonna be CAN 0 if it was CAN 0. If I want to change it from 17 to another CAN device ID, and that's what's being referenced in your code when you program them.
Good question.
Yes.
We can load old firmware in there, right? So it has its practice.
Yes. You saw the drop down on there.
I thought I saw
For the, it has the versions right here on there. And then we've never tried it. We can, you need to downgrade button. I never tried it with a long cable like that. Usually have the short cable on there. What's great about the Rev stuff is, and I'll get you in a moment, if you plug into individual device and don't have them powered up, so what I have my students do a lot of times is we'll take all these components and we'll have them on a bench. We'll plug into each device, and then we'll label them, say here's CAN 1, CAN 2, whatever it is, and then do all the firmware version. Because when you plug that USB in there, C in there, it will power up the device and you can do firmware loading on it and set everything before you wire your electrical board on there. So it's a great utility to do that offline before you're building your robot and then have to start from scratch and do it. So this just shows some of the screens on there on doing that. They always come up with it and tell you it's outdated. Here's the location of that firmware on there, but Rev's utility is really good about going to that directory and already pulling everything out so you don't have to go search for it. And then we saw the writing of the firmware on there. The other thing is, if you're troubleshooting or trying to do a PID loop stuff on here, there's a great graphing utility, and Phoenix Tuner has the same similar stuff on there where you can tune it by graphing it out. And if you get it, you can actually run the motors from here. If you got power to the board and to your motors on there, you can do that. And it's a good tool to test everything prior to putting all your code in. Did you have a question?
Really close to the last season, sometimes when we try to burn the flash, it doesn't stick, and we have to do it multiple times, sometimes 3 or 4 times. Like, is there a reason that it won't stick, and what, you have to burn the flash again, or is it just, you just have to keep doing it over?
So, did you have the board powered up and and you were trying to burn firmware from one device over to another one?
Firmware, but like as
Yeah. A lot of times I like to do that and make sure I'm plugged into that device. Sometimes we've seen it at the regional events where you're plugged into one device and you're talking to a device down the chain. We've seen issues like that, and I don't know if they're addressing it in the new release of this
So your recommendation would be connecting to the actual
device, if you can, yes.
Okay.
Yeah. We've seen that issue before. Yeah, you got a question?
Last meeting our team had, we were updating firmware, and with some of our, with our Sparks, with our Spark Maxes, every so often we get one where it just wouldn't recognize the firmware that was already on it. Or we'd have to just fully close the client and reopen it and just mess around with it a couple times per day. We haven't had Spark Max plugged in. Could you tell me why that happened?
I don't have a good answer for you on that one. We've seen random issues before. Sometimes we can't explain it, and that's, you know, when I get the opportunity, I would go back to Rev support on that. And they've been really good to get back to us on that when we do have issues like that.
Sometimes at an event, when I've seen things like that happen, it'll just act like it can't read it. It almost acts like your cable's being funny. With a lot of these Rev devices, they'll have a little button on them, usually a mode or reset button, something like that. If you power it on while holding that down, it'll put it into a recovery mode, and then it usually pops up in there a lot more reliably. Sometimes maybe something gets messed up in the firmware, something didn't write correctly, but if you put in recovery, reflash it, and set it back up, it usually fixes it. But it's getting better with time. There's been more issues with the Rev client in the past, but they've been doing a lot of work on it to improve it.
Right, and in this slide here, we put that down. It's not perfect. There's some quirks in there we've seen, but like Logan just said, it's getting better every release of it. And Rev does a really good job when you bring it up. You can check for updates on there. They'll probably not push out anything to kick off on there, but I'm excited to see what they have to offer on there. Because there's a battle between the CTRE and the Rev stuff. They're both going so fast on their new motors and that, and things needed a little time to shake out. But there is advantage with the Rev where you can plug directly in and power the device to do your pre-configuration. That is a nice shining point of that. So if you don't take anything away, make sure you update everything. And if you don't, flash the individual components, you know which one you're talking about, which one you're setting. You'll save a lot of headache down the road when your programmer is trying to talk to a certain motor and something else is trying to run it. So we're all on the same page, from programmers to the builders team, and getting your network all to do talking together. Is there any more questions before we move on? Yes.
Just for like the RoboRIO, is there any difference between the two RoboRIOs that the SD card?
So functionally, they're the exact same. They're cross-compatible. The main difference is the spec sheet. So this one has a little bit more RAM, faster processor, just a little bit bumped up internally. It also has a newer hardware revision, so they fixed a lot of hardware bugs that existed in the old one. But functionally, they're equivalent. The only thing that's different really is the SD card thing. We have to image them differently, but.
Does it come with an SD card if you order a new one?
It does. I will say from experience as a CSA, I don't recommend using it. We have seen a lot of them fail out in the wild. They're the little A-Pacer 4 gigabyte cards. I would get your own, usually something like a SanDisk Industrial, just a well-known name brand. They can be any size. You can format it with that tool and it'll just write whatever the image is.
Does it run off that SD card while it's in there? It runs off it, right? Not loaded internal to it.
Yep.
So you have
Yep.
The image and your code go to that SD card.
So it's probably okay.
Yep. Won't run without it. Next, we're going to move into radio configuration.
Yes, so your radio, which is this white box right here, we have a set of older ones that still look like this. This will be the radio for another year, and then it's going to move to a new one, thankfully, because this one's long overdue to be updated. But the way this works is when you're at home anyways, there's a radio configuration utility you can download from the documentation for the control system. And it'll look like this. The first thing it'll ask you is what network interface to select. For most of you, it's just a laptop. It'll be the only one it shows. But to get this started, when you open that utility, you'll just have your radio powered on like this. You'll have an Ethernet cable going to it, and that's going to go to your laptop. And this is what that looks like. It's an older Java application. It's the same thing they've had for about 10 plus years now. It's really, really simple to use. You just type in your T number. You'll select what type of radio you have. So these ones are called the open mesh radios, these white boxes. There is also, I think, the D-Link option still in there, which is a really old radio from like 2013-14. You can still use it in off-season and for practice if you want to, but most people don't even have one at this point. Then you can select the mode. It'll ask for 2.4 gigahertz or 5 gigahertz. I would do 5 gigahertz. 2.4 is for if you have a really niche use case, like you're using it across a parking lot at a demo for a sponsor or something like that. 5 gigahertz allows it to be more reliable and faster speed, so you can be running it more reliably. But yeah, team number, WPA key, you don't really enter that for using this at home. And then robot name is optional. That's just if you wanted to just distinguish it from another robot that maybe has your T number as well. It just, when it shows the Wi-Fi name, it'll be the T number / your robot name. So that's optional. Then just hit configure, and that will take a moment to do that. Sometimes if your radio is really old, like maybe if it's this one, it will also ask you to load firmware. So that's a slightly different process. It'll tell you that, and then you'll just hit that load firmware button, and it'll tell you exactly what to do. It shows all the instructions on the screen. This just says to power cycle it, plug it back in, wait a moment, and it'll just do that for you.
Question.
Yes.
I had a quick question. I thought I heard something about, are they only using this radio for another year or two, or is it, are they,
One
they
more
have
year.
the new radio coming out so they can start?
They've been doing some testing with it, but they're gonna wait one more year before they use it. So 2024 season will still use that open mesh radio there.
Yep.
So
The key about this is when you do the firmware, it's on the boot up. When you go to the events or doing this at your schools, make sure you wait for the radio to be fully booted or else it will not work, okay? Usually at the events, the CSAs are kind of around that table to get your radio configured. I like to tell teams, do it right away when you come in the pits and you're trying to go through inspection. Pull that radio off, go to the kiosk and get it programmed right away. My team also uses a backup radio, so after everyone gets kind of done, we usually do a second radio just in case. If there's connection issues on the field, we have another radio just to plug in, zip tie on the robot and play a match if we need to.
You notice that a lot of problems that we gotta make sure that power level is good when in the source, make sure you're using the DC plugs on programming in the past. We usually use a wall power when we're trying to program them all.
Yeah. We haven't seen anything with the new Rev Power Ethernet there module there. It's a passive PoE, and they've been really good. We haven't seen fail. A couple teams have seen some things, but overall, you got to remember these radios were never designed to be on a moving robot. These are made to sit on a shelf. They had the barrel jack in there, and before these other devices came out into the FRC world and FIRST, they would use the barrel jack, and then what would happen is they'd vibrate and they'd break the solder leads on them internally. So then people would take them apart. They'd put some heat, electrical static type adhesive in there and put the radio back together. They would put different things on there to hold it in there. We like to use a 3D printed one to hold the cables in there, make sure they're taut in there. You know, but the barrel jacks were really susceptible to vibration.
I know the PoE plan on that is actually designed, I think, for 24 volts, so it's actually useful all this kind of.
Right, but the new one was 18 on there.
Right.
Yeah, it works within a range.
Right.
So this Rev one puts out 18 volts, which is at the higher end of the range for that. But
Well, no, but I think the thing with the PoE inputs, when you're running off power over Ethernet, if you're not running the barrel jack, I think that ran into problems with some of them a little bit. We've noticed that with our programming once in a while, it drops over. But if you look at the specs, actually going for the radio, I think the spec is at the 24 volt PoE. It'll run on 12, but then when it does when you actually program it, it can sometimes have troubles if you're trying to run at a lower voltage.
Just like if you're not using the Rev, you're using the VRM, you gotta use the 12 volt one, the 2 amp one on there. And use the voltage regulator so it constantly adjusts for the voltage of your battery. And so I'm a big proponent using the Rev one because I didn't see any issues. I like that RJ45 to snap in place and you hear that click, which is good. Sometimes when you see voltage things, you gotta pay attention to Ethernet cables because there's the 2 wires in there in that bundle that are causing the power on there, and a lot of flexing on there or wrapping on there. Sometimes you'll see them different voltage. You try and keep it as short as possible. I like to keep it nice and tight.
Yeah, so this is just some of the status lights on it. The blinking blue, so that means it's booting. And again, like he said with these radios, they take a while to boot up. It's about 45 seconds to a minute. And they'll throw you for a loop because when you plug them in, that light will go solid and it'll stay solid for like 10-15 seconds. So you think it's powered up and ready to go, but it's not yet because it'll turn back off and turn back on, and then do that same thing and be ready to go in about 45 seconds. That's another downside of these radios. It's why they're leaving them. They take a very long time to start up. So if you lose connection on the field due to a power cable wiggling or something like that, you're down for like half the match. So that's improving. Some of these lights on there, the red just means it's in bridge mode. Yellow is also bridge mode, linked or unlinked. That's what you'll see when you're on the field. So what those do is they will no longer broadcast to Wi-Fi, they'll connect to the field's Wi-Fi. But at home, you'll see the green, which is AP mode, which means it's broadcasting Wi-Fi for your laptop to connect to. Pretty easy stuff. This is a couple different ways you can hook it up. There's the Rev option there where you connect the Ethernet cables to it and it does power over Ethernet. That is the recommended way. A way that has been a thing before that came out was with that cable there, that orange one, where you would plug that into a VRM. So like a CTRE VRM or something on one of these. You would plug that in and that would just give it 12 volt that's injected into the PoE cable. These work, they're not recommended because it adds a couple more failure points. You have to get that VRM correctly, you have to get the wire done correctly. Some of those PoE injectors are a little shaky internally. Some aren't manufactured to the best standards. But that is another option. Generally, we do recommend power over Ethernet when possible. We've had good luck with the Rev ones.
Yeah.
Yep.
We ran a few
Ethernet 6, Cat 6 cables, shielded.
We have one of our proprietary Cat 5 cable got used accidentally. It wasn't a standard patch cable, so there was no wires in the pins.
So the driver station here, we're going to kind of go into some of this on here. If you haven't done the beta one on here, this is the beta right here running, connected to the board over there. Basically looks the same. There's no other knobs in here, but you know, you want to pay attention what Logan mentioned earlier about the firewall and stuff like that. That will show up on the status on here. These knobs here, and it also tells you all your version of your firmware in that, and that's usually where the FMS will catch it too if you're using incompatible firmware or something, someone forgot to change it, or you have the beta left in there. You know, these things do not play very friendly with the FMS when you're in an event. And then you have to put your team number in there as well. So here's a little bit about the firewall stuff, and they got the network stuff in here for the public, your domain, and all that here, and then that'll show up in your status there. The other thing is when you first install it, it will default to the default board here, and my team uses shuffleboard. I'm a big proponent. I wish they would get rid of the smart dashboard, but it still shows up. It's still there. There's a lot of teams still using it. It's very viable if you want to. And then getting into some of the debug stuff. So if you do have trouble with your robot and see different discrepancies and stuff going on, and some sluggishness going on, or something not working right, there's these log files that come up in there, and they're very helpful for the CSAs because we'll come to you and it will show us every match you're in. If it's a qualification match or a practice match, we can go right to that match and it'll give us all the data that's happening. It'll show all your power consumption on all your channels on your power distribution boards. And to get to that, they're over here on this side. There's different ones here that can scroll, but then if you go to this right here, you can go to the view the log file, and they'll come up like this, and you can see right here we've been running it today, so it's just different things on here. But you know, up here you can tell if the robot was in auto mode or telyap, so if something happened between auto and telyap, there's a good way to come in here and see what's going on. Or did you lose a connection? Are you losing packets? You know, is one of your power distribution, like a motor's pulling a lot of current? This is where we go and look at all this stuff, and you can turn them on by these knobs over here and do a different filtering. And then you can zoom in as well and go through the trace. You can just do an area like this. And then if you mouse over it, you see the voltage down there in the lower left-hand corner in yellow. It'll tell us what the voltage was on here. And then up here, it will tell us the teleop stuff here, and auto. And then right here is your CPU time here. So again, it's very helpful for us CSAs. It's our diagnostic tool on here, and it works with any software version you're using. If you're using LabVIEW, Java, C++, or the Python coming out this year, this still be logged in the RoboRIO. The other thing, if you have code crashes and stuff like that that kind of come up, you can look at the console, and this is a run log. So if you're using the visual code and you see that real log come up, popping up if you're using visual code still after you deploy it, this is basically the same window that's being pushed out here. And so you can see if you have a code crash or something got called that shouldn't have called, this is where you'll find it in your log here. Smart dashboard, like I said, is still there. You can put widgets and stuff on here as well and bring different displays up on here. You can break down your subsystems and running and doing your PID loop training on there. This is a good helpful tool for that. The shuffleboard has a lot of different features on here. You can do the same type of thing. It's a little more updated than the smart dashboard on here. And we have one running right here. There's a lot of widgets in here. You can bring up the FMS system on here. This is where you can put your auto choosers right here for your different autos on here. You can do your camera streams on here. And if you didn't know, when you got it connected on here, you can go to the source here, and if you did have a camera server on here, it'd show up on here, and then you could drag it over and put it on your dashboard here. Same thing with your network tables. All this stuff shows up. You can see right down here we have some targets and stuff. We use this to configure stuff all the time on our robot, like set points and stuff on our actuators. If I'm going to a certain set point on an elevator, or a set point if I'm rotating something on there, we'll use this to tweak it so I don't have to do a download each time. We can push it to the shuffleboard and do it. You can get values from right here. You can display different things, and then if you right click on these, you can change it to a graph wherever you want on here. So you can show it as a different type. I can do it as a simple dial, and you can just drag these larger on these, snap on these grids. It gets to it. That's why I use a mouse still. But features are all on the right click function of these. And then there's widgets in here that you can pull up, like the dashboard stuff here. They actually have a field on here too, if everyone's noticed it in the past. Just flew by it. Right here. It has last year's field on here. So when the new game comes out, releasing a new pack, we'll have the field eventually load up on there as well. A lot of people on these cameras don't even set this, but you can set your camera compression and frame rate and view on here. And it also has stuff on here like you can remove the crosshair and stuff if you don't want that on there. You can take it off, put it on there. You can change the color and stuff on there by this utility right here. And change that view. So a lot of things you can do to help debug code and stuff like that when you're going through your iterations and you're doing your build to do stuff with that. It's got a little sample code there. And then before we do that, I wanted to show you there's nothing on that motor, Logan, that Falcon. One thing that I like to do is if you go into test mode and you enable the robot, and if you have your shuffleboard or smart dashboard set up correctly, you can go to the live window right here, and then I can actually spin that motor in test mode. How many of you guys knew about that feature? It's very helpful, especially on your drivetrains and that. You want to check direction right away. You can ungroup it and spin each motor individually, so you can get your direction set right. And it was more prevalent when you're not using Swerve, because Swerve's got its own stuff to worry about in Swerve with absolute encoders and direction and set offsets and stuff. But on your actuators and stuff and your intakes and that, if you want to make sure that how it was mechanically mounted, that you can come in here and go in test mode and go to the live window, and these components just show up. So I can run it both directions, so I can go ahead and make sure that is, so when I code it, I know which direction it needs to go.
The network devices on your robot talk together. It's how the radio communicates with your RoboRIO. It's how your RoboRIO talks with your laptop in the field. It's also how, if you have a network switch, this is how you add more Ethernet ports to your robot for things like a Limelight, Raspberry Pi. Those are all signed by IP address as well. The RoboRIO, well actually the whole robot, follows the IP addresses handed out from your radio, and that's based on your team numbers. It'll be 10. If you're 4607, 10.4607.1.2. Whatever beyond that. The RoboRIO is usually at .2, but that's how IP addresses are set. That's how your network looks like on your robot. Any questions about that stuff?
So when you go to the field, make sure your computer's just set to dynamically DHCP. It's very critical that you can static it, but they prefer you run the dynamic on there so that FMS can set it from FMS on it. We'll go quickly through some troubleshooting things on here. There's all in the manual on here, but as you saw on the light there, if it's a solid light on from your road signal light, you saw one was disabled, it flashes when it's enabled. These are just troubleshooting things. So I always tell teams also, when you're doing your designs and stuff, have a way that you can kind of see your lights on here, because the FTAs look at these lights. If you're having connection issues to the field, they look at these lights, and that's how they can help troubleshoot things if something's not working. So they can look at the comm lights on there, see if the radio's connected and all this, and see if it's a radio issue or if it's the RoboRIO not booting correctly. And then we're not going to go through these slide by slide here, but they're in the RoboRIO manual that's installed with everything on here. But all these lights mean something. We use it at CSAs to troubleshoot as we go on there, if it's communications or not. If it's an E-stop, it'll be a solid blinking light for the E-stop, solid green for good communications. And if a brownouts or anything happens like that on there, robot's disabled, you'll get the other lights here. And the same thing in all the components on here. You'll see a lot of times the sticky faults that come up. And again, go through this. The Rev's got their own different color pattern in there, and we usually post that on our Trello boards and that, so we can go through, because we can't memorize all the different light configurations on there. But if you do see something odd, the main point is here, these blinking lights are happening on your devices and stuff. We'll have a meeting to it that you need to address on there. So again, Spark Max here, and this presentation will be posted on our Jumpstart Robotics website, as well as the stream that you can go back and watch the video on. Limelight is another huge thing that we've been battling over the years on here. This is one device you will static IP address, and it's usually .11. And there's a whole utility. Corey Applegate's got a big presentation on Limelight, but there's a lot of things on here. Here's the network things on here, how you can go into the web server and configure it. And there's other utilities with that. We won't go into specifics on that, but be aware there's lights, and then team number, like Logan was saying, 10.team number .11 static year line lights. Don't run the DHCP on them. It just doesn't play very fair on there. And then there's different code samples on there and that. We try to give you as much as we could on different practicalities of what we've seen when we troubleshoot different robots. Make sure your CANDs and all that and your firmware is up to date. And the big thing we want to also leave you point with here as we're wrapping up is pay attention to the team updates that come out. Because first we'll update the firmwares, or there will be new images of RoboRIO sometimes that come out. The beta for the last couple of years is wide open. This year was really wide open. Anyone could go in there and get the beta code and test it out yourself. And we like to do a little bit of it so we're kind of up to date before the season kicks off, see if there's any breaking changes in some of the calls. But the team updates will have that in there, so pay attention to them. And if it is, for me, it's not an option. We always update to the newest firmware and images that FIRST puts out. It just saves a lot of headache long term because you don't know what some little thing that's nagging you and you can't figure out what's going on, and it's because it's broken.
And it is not uncommon that they will do a massive update of your driver station or even a RoboRIO image the night before an event. So just make sure you check on that, make sure you stay up to date. I think they even have a way you can subscribe to get emails about it too, but they will alert you of that, and you need to come prepared to events, otherwise we have to go around pit to pit and help everyone get updated so you can actually function on the field, but good to keep on top of. Don't fall behind on that.
And again, you know, the CSAs are here to help. We work closely with the FTAs on the field to keep everyone up. Our job is to keep everybody running an event. The resources here, he's got the 0 to robot thing on, which is super helpful on there. And then the individual vendor documentation on there. The quickest way to get to a lot of this is to say FRC docs in your Google, and it will bring you to this website. For installing all the software, everything will be usually updated pretty regular on there. If there's a new update, now you can bookmark that and check everything out on there as well. Again, any questions, come reach out to me and Logan. Our Jumpstart website here will
Have this stuff posted on there, as well as be on our YouTube channel, and then FIRST Updates now will have this presentation next week. Any other questions? We're getting to science lunchtime, so. Well, thanks for attending. Have a great rest of the day.
night's not over. The dawn's not that far away. Hop back on the saddle soon. You saw this soldier. The dark can consume your brain. All we ever wanted was a little air to breathe. But all we got are ashes of our old memories. They can try to take me down, but they can't take me to my knees. No, you'll never take me. Not my choice, but it's my blood to bleed. I'm fading. Don't suffer no fools. Serpents,
Drinking Kool-Aid cameras like I did when I was 9. Cause I like to pretend that I haven't lost the time. In the end, the nostalgia, though it tastes fine, I can only drink a couple cause it feels like a lie. We'd play Halo and we'd lay low in our basement until the sun began to rise. We would go to school but not learn too much, cause it's hard to read when you've got tired eyes. Months go by, the time it flies, past the days that we drink Kool-Aid in the summertime. Years go by, the time it flies, past the days that we drink Kool-Aid in the summertime. They've been with me for some time, and it's nice to know that they still by my side. Friends are like stars, cause no matter how far, when it's dark outside, they will be your light. We'd play Halo, and we'd lay low in our basement until the sun began to rise. We would go to school but not learn too much, cause it's hard to read when you've got tired eyes. Months go by, the time it flies, past the days that we drink Kool-Aid in the summertime. Years go by, the time it flies, past the days that we drink Kool-Aid in the summertime. Mom, today sucked, I'm not feeling great. People all laughed and they call me names. Why's it so tough and the world so lame? Can I have some cash and a ride down to the arcade? This morning blue, I stayed up till 2. People stare at me like I'm trapped in a zoo. Why's it so tough and the world so lame? Can I have some cash and a ride down to the arcade? Some cash and a ride down to the arcade. Can I have some cash and a ride down to the arcade? Can I have some cash and a ride down to the arcade? Why's it so tough and the world so lame? Can I have some cash and a ride down to the arcade? Some cash and a ride down to the arcade. Can I have some cash and a ride down to the arcade? Can I have some cash and a ride down to the arcade? Can I have some cash and a ride down to that I'm the only one, the only one. I guess that I'm the only one. Although it hurts, I know that you're the reason I feel down. It's time to let it go. 'Cause we don't work, and I'm tired of trying to turn it all around. I'm rising from it all. We started out strong, until the end, you gave me something I couldn't live. I guess that I'm the only one. I guess that I'm the only one. We started out strong, until the end, you gave me something I couldn't live. I guess that I'm the only one. I guess that I'm the only one. You gave me something.
I told you that one day ain't never enough. You tell me I hate you, I still call you up. If we don't got trust, we can never have love. I was putting in the hours, I was. But you were calling me a liar, 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 liar. Yeah, I've been putting in the hours, I was. And it's coming down to now and now and now and now and never. I was putting in the I'm sick of fighting the things that you said. I don't wanna burn all our bridges ahead. I'm tired of going to bed when you left me on red just to turn up the noise in my head. I told you that one day ain't never enough. You tell me I hate you, I still call you up. If we don't got trust, we can never have love. I was putting in the hours, I was. You were calling me a liar, 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 liar. Yeah, I've been putting in the hours, I was. And it's coming down to now and now and now and now and never. I was putting in the putting in the feel your touch like ice, tracing all my scars. Why does it hurt on the inside? It's unforgivable, but I forgive you every time. Hard to let it go, 'cause we're intertwined. I break you, you break me, but something about it makes us whole, baby. Every piece keeps us together in the cold. I break you, you break me, holding on. a cold light. It isn't much, but it's all we needed. It's all we needed. With everything in its right place. Don't push away, 'cause it's all we needed. To control and moment. All it takes is a moment. Is it fate that you came this far unbroken? If it's destiny, you wrote it. Focused, but you gotta be focused. Make or break, it's the last goodbye they remember you for. They're calling your name, go and take what's yours. Here, now, it's everything you've been dreaming about. There's a reason why you were chosen. This is your moment. when you need it most. Feel the freedom of being careless, just being in love. Everything will be alright. Through the darkness, through the night, no fear anymore. No fear anymore.
guys, I think we're ready to get started. So this is Vision Programming with AprilTags for FRC. I'm Andy Gosser. I'm a Java programmer with Team 7028 out of St. Michael Albertville, the Binary Battalion. Been working with them since their rookie year in 2018. And I like to do programming and control systems. And I'm going to be a CSA at the Granite City Regional in St. Cloud. So if you have trouble in St. Cloud, come find me. I can hopefully help you out. Can you guys hear me okay? Is it all right? So first question, what are AprilTags, right? AprilTags are these kind of barcode-y looking things, but by looking at them, a camera can tell the, yeah. Uh-oh, it's flickering here, maybe it'll come back. All right. By looking at it, a camera can tell how far away it is, what direction it's pointed, and its orientation. So the pictures that are up there, I took those at the EMCC 2 years ago and then ran them through an AprilTag processor. And you can see there's little boxes that it can identify that, oh, this one's turned this way and that one's turned that way. Interesting, there's kind of this one in the corner that doesn't show up. AprilTags do have to be flat and like mostly visible, including the white border, for them to be identified. So that's what AprilTags are. For FRC, they're going to this year use, there's different tag families. They're going to use this tag family. It's 36H11. There's 587 different tags. Last year they used a family that only had 30. Kind of hoping by allowing more, they're going to have more tags on the field, but we don't know yet. So last year, my box on the right there was a lot bigger. There was only 30 tags. Now there's a lot more options. This is the size they're going to be. They're going to be about 8 1/8 by 6 1/2. So why AprilTags instead of retroreflective tape? We've used retroreflective tape in FRC for years. Kind of that bottom right corner shows what a camera sees with retroreflective tape. We would have a bright green LED, usually a limelight, and turn the exposure way down so all we could see was the green reflection coming back. And then the top right there is an AprilTag. It's kind of the same position that we're seeing. There's tape on these poles, and here we're seeing just the tape reflected back. One big advantage is we don't have to have bright lights on our robots. The limelight, everybody kind of complains it's shining in my eyes, and in the pit, nobody can see. But it also gives us that 3D positioning and orientation. We can tell how far it is from the camera and what direction it's pointed, so we can pinpoint where the tag is in relation to the camera. And then each tag is unique. So on the previous screen, we saw all those different tags, over 500 different tags. The camera can identify that's tag number 1, that's tag number 2. Where with that retroreflective tape on the bottom, I have no idea which node that is. Is that the one on the far left, the one on the far right? No way to know. And it also needs less calibration at the competition. If you can see with your camera, you can most likely see AprilTags. There's some optimizations you can do, but you can most likely see it. So there's less need to drag your robot out and make sure every single node can be seen and all the reflections and everything. And it's also less susceptible to field lighting and arena LED signage. We had a big problem in 2022 at Williams Arena. They have a big marquee that goes all the way around. They put green on that, and then our lights wouldn't, or our camera couldn't pick up the retroreflective tape. So last year for FRC, they used 8 different tags, and they were near the scoring locations in the human player double station. So the top there is a picture. You guys probably all have seen one of the events, at least at an off season. And then the bottom right shows where all those tags were. So you'll see there's 8 different tag IDs. So if you can see a tag, you can know which tag you're looking at and then where you are on the field. So we're going to cover 2 different ways to deal with AprilTags in FRC. Using a coprocessor is the way that we do it. So a coprocessor is another processor besides your RoboRIO. Your RoboRIO is kind of your main processor. By offloading this, we can do it faster and have it impact our robot less. Photon Vision is a great solution. It's less expensive than Limelight, which is our second option. It can identify AprilTags, but it can also do retroreflective tape and color shapes. They have a library that you can integrate into your robot that makes it really easy to interface with. You don't have to deal with network tables or whatever. It just makes it very simple to work with. So Photon Vision is really designed to run on a Raspberry Pi or a Limelight. A Limelight internally does use a Raspberry Pi compute module. A Glowworm is kind of this open source camera that was available for a few years. You can run it on other systems too. Some teams run it on like a mini PC. More powerful systems definitely works too. But a Raspberry Pi combined with one of these cameras, you can get a pretty good solution up for around $100, which is a pretty good deal in FRC to get something going for that price. As mentioning cameras, there's lots of different options, but this OV9281 global shutter camera is one of your best choices. And you want to use a global shutter camera if you can. That illustration at the bottom shows kind of what that means. So that ideal with the horse running, that's kind of what your eyes see, right? The horse is running over time. A global shutter is that middle picture. What it can do is open the shutter and capture the entire image in one pass. So it gets a frozen snapshot of the horse running. A regular camera, like even a Pi Cam or the Life Cam, the other options there are rolling shutter. So they'll open up the shutter and then they'll read the sensor from the top to the bottom. If your robot is moving really fast, you'll end up with how the legs get torn there. Your tag will end up getting distorted, so you won't be able to see it as well. So Photon Vision with Raspberry Pi is a great option because you can use a global shutter camera. The Limelight is the other option that we'll cover. You guys are probably familiar with the Limelight. It's been around for several years now in FRC. It's a full out-of-the-box solution, but it costs, depending which one you buy, $350 to $400. Last year, they created a helper. It's called Limelight Lab that you can put into your code to make it easier to interact with. Otherwise, you had to do network tables. And it's open source. I've sent them some pull requests and gotten some stuff added, so that's really great. But Limelight doesn't have a global shutter camera option, at least as of now. Their reveal video did say global shutter expandable, something like that, but they haven't released any sort of solution for how that works yet. So I don't know if for this year there will be an option or not, but that's something to consider, is that if you can use a global shutter camera, you might get a little bit more reliable detection. So just talk real briefly about camera configuration. This applies both if you're going to use Photon Vision or Limelight. What you want to try to do is set your exposure as low as possible, because that means the shutter is open for the shortest amount of time. And so you have less chance for smearing of the image. So having it as low as possible is good, and then use the brightness or the gain to try to boost it back up so that it's visible. And then your resolution, lower is going to be able to process faster to look at the image and find the tags, but a higher resolution is going to give you better range and accuracy, because if you're looking really far away, if you use a lower resolution, you're going to have less pixels to see. Yeah?
How low is too low for exposure? Like how do you see the limit of how low you can get?
I'll do a demo with Photon Vision, but you can see a live view of what the camera sees, and then put a tag in front of it and try to adjust it based on what you see.
Can't recognize it at all when you're too low.
Right.
Okay.
Yeah. Yeah. So we still did do some calibration at the events because the lighting is different than in the shop, but it's a little bit easier to do. So. One extra step that you have to do with Photon Vision that you don't have to do with Limelight is camera calibration. When you first get it set up and installed, you have to use checkerboard. It has right in it, you print out the checkerboard and then just measure it and make sure the size that it printed right. And then you have to hold it in front of your camera at different orientations for it to calibrate. And what that's doing is looking at the way the lens and the camera capture the image to find out, you know, how the distortion is and everything, so it knows then how to be able to detect the tag and the distance and its orientation. So you don't have to do that with Limelight because the camera is built in and it's an out-of-the-box solution, but with Photon Vision you can use any number of cameras, so you have to go through that extra step. Both Limelight and Photon Vision later in the season last year implemented multi-tag pose estimation. If it can see more than one tag, it can get a better estimation of where you are. So Limelight calls it mega tag, Photon Vision calls it multi-tag estimation. This year they'll be able to run it on the Raspberry Pi. Last year you had to run it on your RoboRIO, but the takeaway from this slide is find that setting and turn it on and make sure that it's working, because it really helps reduce ambiguity and noise. If there's little ambiguity really happens when you're looking straight on with the tag. The camera's right here looking straight on it at 180 degrees. It has a difficult time telling the orientation, so you'll have kind of jumping back and forth. But if you had another tag that's right here, that one's not straight on, if it can see the two, it can really reduce the ambiguity. So it's a cool feature. It's fun to turn on. So now we'll take a peek at Photon Vision. So I have it actually running right on my laptop. You wouldn't do that on your robot, obviously, but you can do a good demo that way. So this is the Photon Vision interface. I have it kind of, my screen resolution low so that everything's a little bit bigger, so you can't see as much as you normally can, but it's here. When you first start it up, you have to go to the settings tab, just like with Limelight. You have to go in here and set your team number. I have localhost because I'm running it on this machine and I'm going to use it with the simulator, but you would put your team number in here, and then you should also set a static network address. You should do that both with Photon Vision and with Limelight, so you always know where to find it on your network. So then this main dashboard tab is the one where you can see the camera and do all your calibration and configuration. So we have our camera selected, we have a pipeline. A pipeline is just a different configuration set, so you can have multiple configurations. If you can use the same camera to do retroreflective tape and to do AprilTags, or to be your driver camera and to do AprilTags by having different pipelines. So this one's an AprilTag pipeline, and then we'll skip over this for right now. And then so here's your input. On this screen resolution, it's very difficult to see here. Did I? No. Let me see if I can make it. So normally it'll be like this, where this shows up over here, so you can see settings at the same time. So if I put a tag in front of it, I should see it, hopefully. Yep, there we go. And so we were talking about exposure before. We would want to try to bring our exposure down as low as we can and have it still detect the tag at the distance that we want. So, but you can also bring your brightness up. But this would be your basic calibration that you'd want to go through. It also has an auto exposure setting that works pretty well. And then here you can choose the resolution for your pipeline. So mine is running at a very high resolution. The frames per second, it comes along with the resolution here. Obviously, if you're capturing more frames per second, you can process more frames per second. If I choose one that only does 10 frames per second, I will never get more than 10 frames per second. Up here it tells me what it's actually processing at. I'm on a laptop, so it's processing as fast as the images are coming in. On a Raspberry Pi, you're lucky to get 30 frames per second is pretty good. So we talked about calibration real quick. That's another thing that you do have to do before it will do the 3D tags. So here, by default, it'll do these two-dimensional tags. It can identify the tag and give you a little bit of information, but if you want to also get that distance and orientation, you have to do calibration. So I already did that step, but we do that on here. We would say start calibration, and then it'll show up here, and you put this in front of it in a bunch of different orientations and capture the images, and then it will calibrate it for you. Any questions so far? Yeah.
Go back down to the resolution.
Sure.
The value that's behind the comma, is that what the codec or something like that?
This one? Yeah, yeah. The value right behind is the codec coming.
Is there any meaningful differences between the MJPEG or the other one?
Well, the MJPEG would be a compressed format, where the other one would be a RAW format. Depending what camera you have, I'm using the webcam that's built into my laptop, so it's kind of different than what you'll really see. But yeah, I would generally not choose a JPEG format if I can. But see, at this high resolution, there isn't a fast frame rate that's not compressed because there's too much data going over. So if we go down, I'd have to go down to like the 640 by 480 to get a non-compressed format. But yep, that's something to look for. But this will completely be dependent on what resolutions your camera supports. Yep. All right, any other questions so far? Nope. Great. So I guess one other thing we can peek at here is as I show this tag, and so I don't have that resolution calibrated, so it won't let me do 3D. That one, that's the only one that's calibrated. So here it shows me 1280 by 720 is calibrated. The other ones are not because they don't have values. So I have to go back to 1280 by 720. Hopefully it didn't break. There we go. And then I can do 3D. Down here it gives me some data about the target. So it tells me the distance it thinks it is from the camera, how far left and right of the center, and then its orientation. So see, when I get close to 180 degrees, and it has also ambiguity. It can see this very well, so it's not ambiguous at all. But if it was very far away or kind of dirty, you might get a higher ambiguity, and that might be something you want to try to filter out, the ones that are more ambiguous. All right, so now we saw kind of how you can detect the tags. What are you going to do with them? That's really the thing that we want to know, right? So just quick background, WPI Lab is the library that we use, for FRC programming. It has some classes built in that help us deal with coordinates and poses. So those classes are translation. A translation is just a point. In two-dimensional space, it would be just an X and a Y. In three-dimensional space, it would be an X, Y, and a Z. A rotation is just that, a heading. 40 degrees, 90 degrees. And then a pose is the combination of the two. So if your robot is sitting on the field, it is sitting at a point and it is facing in a direction. So a pose is our translation and rotation. And then a transform is how it's a vector and a rotation to get from one point to another. So if we're at one spot to get to the other spot, it's what's the difference between the two. So I can apply the transformation to go back and forth between those 2 points. So the transformation is important because when we see an AprilTag, that's essentially what we're getting. It's telling us how far the tag is from the camera. That's a transform from the tag to the camera or the camera to the tag, depending which direction. And then our rotation, if we're in three-dimensional space, there's a yaw, pitch, and a roll. We do get all of that data from an AprilTag, but really our robot, we're just going to assume it's always on the ground sitting forward, not tilted. So we usually do robot poses in two-dimensional space. So we don't care about pitch and roll and its height off the floor. We just assume it's on the floor, not tipping over. Another thing that is important to understand is FRC's coordinate system. It's sometimes not intuitive that X is forward, robot forward is X, not Y. So positive X is forward, positive Y is to the left, and positive rotation is counterclockwise, not clockwise. So this is how it works on a robot. X is forward, Y is to the left. And then on the field, our alliance station is 0, 0. So this is if we're on the blue alliance, this bottom left-hand corner is 0, 0. And if you're standing in the alliance station, forward is X, positive X, and to your left is positive Y, same as a robot. And then rotation is also positive to the left. But if you're on the red alliance, 0, 0 is in the top right. And so this is where it gets kind of confusing, and it used to not matter, right? Because we didn't have AprilTags on the field, and the fields were always rotated images of each other. Well, last year, they're a mirror image of each other. So your coordinates of your nodes changes if you're on red or blue, and when you see a tag, you have to know which side it's on, because they're not mirrored. Tag number 8 is over here on the bottom left, tag number 1 is over here. So the coordinates change depending which alliance you're on. So that's something that is important to grasp. So our ultimate goal by seeing one of those tags is to figure out where the robot is on the field. That's really what we want to do with AprilTags. Compared to retroreflective tape, we were kind of seeing a target. We didn't care necessarily where we were. We cared where we were relative to the target. We try to turn left or right, drive forward, backward, whatever, to get to the target. AprilTags tell us where we are on the field, and then we would want to use somewhere on the field as our target. So how does that work? We use the tag to estimate the robot's pose by configuring the pose of the tag on the field. So that's where, back here, FRC is going to tell us where are the different tags on the field. So that's built into both Photon Vision and Limelight. After kickoff, at some point, they'll release an update that just has that built in, ready to go, so you don't have to set it up. But then you have to configure where is the camera on your robot. So you measure from the center of your robot to the position of your camera, forward, backward, left, right, as well as the rotation of your camera. Because when you see a tag, it's going to tell you where is the tag in relation to your camera. What you really care about is where is your robot, right? So you have to do that additional transformation. So we have our AprilTag on the field. We have our camera on the robot. This right here is a transform between where our camera is and where the center of our robot is. And then Photon Vision or Limelight knows where the tag is in relation to the camera, because it can, when it sees the tag, it knows that information. So it gets a camera to target transformation. And we can flip that around to then say we want to get a target to camera, because we know where the target is, so we can find out where our camera is. And Limelight and Photon Pose Estimator is a built-in class. They calculate that for you. So if you get everything set up, you just ask the Limelight or the Photon Vision, where am I on the field? And then when it can see a tag, it'll give you an estimate of where it thinks you are. So we do that by using the WPI Lib built-in pose estimators. If you've done odometry before, it's very similar to that. It actually starts that way. Your odometry is, you use your encoders and your gyro, you feed those into the odometry class, and it keeps track of where you are on the field. So you start with that, and then you can feed in vision poses. When you can see a tag and your camera tells you where you are, you feed that information in too. And then the pose estimator handles the math to fuse those two and give you a pose estimate. And you can configure it to say, I want to trust my gyroscope more than my vision tags, or I want to trust my encoders more than my vision tags, or I want to trust my vision tags more. Generally, your odometry is going to drift over time as you get pushed around, or the carpet even moves a little bit, your wheels spin. Your gyroscope will drift a little, but your AprilTags are going to be pretty reliable as long as you can see them and they're not ambiguous. So there's different pose estimators for each drivetrain type. You just pick the right one based on your drivetrain. Differential is for tank, mecanum is for mecanum drivetrains, which we don't see as much anymore, and swerve drive. So here's some code. It looks a little bit scary, but we'll walk through what we're setting up here because it's really not that complicated. So we have to configure where is our camera on the robot. So we said that would be a transform. So we're going to create a new transform. It's going to be a 3D transform because it's off the floor in our case and rotated. So a transform 3D. And then if we remember, a transform is made up of a translation and a rotation. So we have a translation first that has our X position from the robot to the camera. So this is saying that it's 0.06 meters forward of the center of the robot. It's negative 0.2 meters Y, which is negative is to the right, so it's 0.2 meters to the right, and it is this far off the ground in meters. And then our rotation, we're saying it's pointed straight forward. It's pointed upward at 15 degrees, and it was slightly off kilter by 3 degrees also, turned to the side. So now if we get a position relative to the camera, we can apply this transform to find out where the robot is relative to that. So we now have this value. We create our photon pose estimator, which is part of the photon library, and it needs a couple things. It needs first that robot to camera transform, so that's why we set that up. We set it up and now we don't have to worry about it again. We have to tell it where the tags are on the field. That's something that's built into WPI Lib. We can use this right here. And then we have to give it a strategy for how it's going to do the processing. So I talked about earlier multi-tag. This is the multi-tag on the coprocessor. You can also, there's several different strategies. You can tell it like which one is closest to the center of the camera, or various strategies. Multi-tag is probably your best strategy to use. And then you have to give it this Photon camera instance with the name of your camera that's configured in Photon Vision. So I have that configured right here. It's OV9281, just so it matches my 2023 code. So this stuff you set up at the top of your code. You don't have to call it again. And then to feed the information in, you do this. You call photon pose estimator update. And that goes out to the camera and asks if it can see any tags right now. And if it can, it returns an optional with an estimated robot pose in it. The estimated robot pose is a 3-dimensional pose. And it'll be the pose of your robot because you gave it the position of the camera on the robot and it knows where the tag was. So it's telling you where it thinks it is, and we can just feed that into WPI Lib's pose estimator. We're also feeding our odometry information. We give it a 2D version of that, and then you need to tell it what time did it see the tag and do the processing, and that's also just built in. You can just get the timestamp and feed that in. So with this code, now when it sees a tag, it can feed that and fuse it in with your odometry and know where you are on the field. For Limelight, it's very similar. We're gonna get the network table entry for bot pose, and then WPI blue if we're on the blue alliance, red if we're on the red alliance. And then this is doing some extra work to calculate the timestamp and then create the pose based on that data, and then we add the vision measurement. So I was putting together this presentation and I found that it was harder to get the timestamp than it should be. So I sent them a pull request. Hopefully they will accept it. That it would be as simple as calling get bot pose estimate WPI Lib blue, and then it would return an object that has the pose and the timestamp. So hopefully by the time the season starts, it's something as simple as this with Limelight. But even still, it's bringing this code in and just using that over and over. Any questions on that so far? Yeah.
So how would you integrate that with the gyro, like typically integrate it with the
So the question was, how do you integrate that with the gyroscope and get that estimate? So this pose right on this one, this pose estimator, we're constructing that in the same way that we construct the odometry today. When you construct the odometry, you give it your current encoder positions and your gyroscope, and then you call update in your periodic loop. You do the same thing with the pose estimator. It still has that same constructor, and then it has an update method that takes either your swerve module states if you're doing swerve, or your encoder positions and your gyroscope. Yep. So it'll take those two and fuse them together and make a decision about where you are. Yeah.
Can you go back to the Photon Vision, like extension?
This one?
Yeah, no, but the one with the color symbol.
The code? Sure.
Yeah. In the rotation to like the second, is that like, is 15 negative like up or down? Like, what, how does the, what, I guess my question is how does the angle this way work?
If I remember right, negative is the camera is pointed upward.
Okay.
Yeah. But
yeah.
yep, I'm not 100% positive on that.
Double check it.
Yeah, I'm like, yeah, sure. Yeah.
So, on this slide actually, the load tag layout field, is that where it's gonna load either red or blue? Will it load it automatically?
I kind of skipped over that. Yep. So you can. The question was the here where we're doing the loading the tag layout. Does that automatically load the red or blue? And it does not. So the object that you get back from this has a method on it that's I think it's set. I can't remember. But you tell it, are you on the red alliance or the blue alliance? And I think it's blue by default. So you can, there's a method on the driver station that you can call to ask it which alliance you're on. You would feed that in. Right, because the coordinates change depending which alliance you're on. Yeah.
Well, my other question is, why would you want to have two different sets of coordinates and not just say, we're always going to use blue alliance coordinates using this around the red?
You could do that. The question is, why wouldn't you just use the same coordinates? You could do that, but all the tools are built around not doing that. That your 0, 0 is always the corner of your alliance station. So, like last year, we used Path Planner. Path Planner had it built in to know that it wasn't a rotated field, it was mirrored, and it would automatically mirror your paths and your autonomous. So like it was all built around that being the way that you drive. Yeah. Because otherwise, like forward from your alliance station when you're on red would be negative, and so everything would kind of be flipped around. All right. So you can see kind of how it all comes together. So we have this pipeline running. I'm going to just make sure that's still working. Yep. So I have Photon Vision running. This would be running on your robot. It uses network tables to connect to your robot. It's telling me down here it's not connected to my robot. Well, I'm going to run the simulator. I'm going to run my code that I've been working on over the summer. It should, so there's going to be no odometry data because my robot is not moving. But I'm feeding my estimated pose onto this dashboard here. You can see my robot is down here in the corner. What I'm hoping to do is hold this tag in front of the camera. This is tag number 1. So if we go back all the way back here, tag number 1 is down here in front of the red alliance. If I hold that tag here and I hold it here for a little while, I'm expecting it to estimate my robot is right here facing in front of the tag. So hopefully that works. There we go. I have it turned kind of funny. But see, based on where it sees that tag in relation to the camera, it's moving the robot around. So this is where you can configure how much is it going to trust this compared to the fact that the wheels aren't moving and the gyroscope isn't turning. Do I want to trust my AprilTags that much or not? This is just the default configuration, and it trusts it quite a bit, which is probably the right move, because over time it's going to drift quite a bit with your odometry. Any questions? Yeah.
For one, you trust that it uses like standard deviations?
Yep, it uses standard deviations to configure that, yeah. Any other questions? All right. Well, hopefully that was helpful. Thanks. Got just a couple of resources on the last page. Photon Vision documentation. Definitely go to Chief Delphi. If you've never used Chief Delphi, check it out. Lots of good information, lots of good people on there. I like to, I think I misspelled it here. I like to lurk in the technical section, not as much in the other stuff that goes on there, but the programming, if you have a programming problem, post your code there, put it on GitHub, you'll get answers from people very quickly. There's a Discord also for Photon Vision. Lots of people are on there giving lots of good information. Limelight documentation, and definitely WPI Live documentation is the first place to go for lots of info. Well, thanks. Yeah, I'll figure out, I'll send them to these guys, and I think they can get them on the site. Otherwise, we'll put them on our 7028robotics.com.
Okay,
Yeah.
cool. Thank you.